Once again, good afternoon to all. Today we are going to discuss the types of electric batteries. In the last classes, we have discussed on history and evolution of electric vehicles, EV powertrain architecture and energy flow, battery types, performance characteristics. Now we are going to study about the battery types, performance characteristics and safety consideration in this class. So when we start with the electric batteries, why we need batteries for electric vehicle? Why we need? Because the name itself says it is an electric vehicle. Electric vehicle means it is to run with the electric. So the energy that is going to be stored in the batteries, that batteries energy can be utilized to run the electric vehicles. That's why batteries plays a very important role in an electric vehicle. So are the batteries used in the IC engines and electric vehicle same? What is your opinion about this one?
No.
The batteries used in the electric vehicle and IC engines are the same?
No, sir, different.
They are different. So which
Storage
type of batteries
store
are
ಮಾಡಬಹುದು.
used in IC engines?
Long time store ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಸರ್.
Long term we cannot store there. So which type of batteries we are using in electric vehicle and which type of batteries we are using in IC?
Lithium ion battery for EV.
Very good. In IC engines? Lead acid batteries are used in IC engines. Why can't we use these lithium ion batteries in IC engine vehicles? From the earlier stage itself, from the data of earlier stage of IC engine vehicles, we are using the lead acid batteries. So electric vehicles also in the earlier stage of its, it was using lead acid batteries. After that one, when the evolution of batteries happened, as I said in the evolution technology of electric vehicle, presently lithium ion batteries are using. So why can't we go for lithium ion batteries for IC engine vehicles? Anybody? Why can't we use the IC engine, lead acid batteries in IC engine vehicles?
ಲೈಟ್ ವೇಟ್ ಇರುತ್ತೆ ಸರ್, ಮತ್ತೆ ಲಾಂಗ್ ಲೈಫ್,
The main reason
ಫಾಸ್ಟ್
is
ಚಾರ್ಜಿಂಗ್ ಆಗುತ್ತೆ.
lithium batteries are very costly, and the IC engine, the lifespan also is very important. But the main thing is they are cheaper, and from the earlier stage itself they were using the lead acid batteries due to the cheaper in cost. That's why that is the main reason of lead acid battery. But in electric vehicle, the use of batteries in electric vehicle is completely different, and use of batteries in the IC engines is completely different. So batteries are used in the vehicle to, if you consider two-wheeler, for the not for the traction purpose we are not using, but in the EV vehicle for the traction purpose we are using the batteries. So that is the major thing we need to consider. So the battery selection for the electric vehicle depends upon battery's weight, storage capacity, production cost, lifespan, recharging capacity, and environmental impact. So we go one by one. Why the battery weight is very important in selection of the batteries in electric vehicle? Why it is very important? Battery weight. Whether it affects the mileage or cost of electric vehicle or power capacity of the motor. These are the 6 points we need to consider while selecting the batteries. So first thing is the battery weight. If the weight of the battery is more, overall weight of the electric vehicle is more. What happens if the overall weight of the electric vehicle is more? As we know from the last class, the traction effort is equal to sum of the 4 forces. One among them is the M into A. That is what we said, the mass into acceleration. So if the mass is increased, then the total tractive effort is going to be increased. If the total tractive effort is increased, then torque required is also more. If the torque required is more, then the rating of the motor is also high. If the rating of the motor is high, then the cost is also high and the size of the motor is also high. They are directly proportional. One and one are directly proportional. If the battery weight is more, the vehicle weight becomes high. As the vehicle weight is high, then the corresponding parameters connected to the vehicle weight are going to be increased. As everything is increased, the overall cost and overall size of the complete electric vehicle is high. So this is why we need the first point, we need to consider the weight of the battery. Then second one is storage capacity. Why it is important? Why storage capacity is important? You need to answer whatever comes to your mind. You can tell. It's not the way we not judge whether this is correct or wrong. So it is only a discussion.
Better performance ಬೇಕು ಅಂದ್ರೆ storage performance.
If you want the better performance, we need to have the good storage capacity. Then any other answers?
Long drive ಹೋಗಬೇಕು ಅಂತ range.
Very good. The long drive. If you want to run for the long distance, the capacity of the battery should be high. If the capacity of this battery is less, then intermittently we need to charge our battery. We are not in the stage of for every 100 kilometers or for every 50 kilometers we cannot charge our battery. We don't find any charging station for every 50 kilometers. If the storage capacity of the battery is high, then the long run can be done. So that is also a very important thing when we consider the selection of the battery. Then the third one is production cost. So how this cost is related? If the battery of capacity maybe 200 kilowatt hour, you have the cost of 20,000. If the same capacity by any other company gives for the 60,000, then which one you will prefer? 20,000 battery we will prefer, and the 20,000 battery, the production cost of 30,000 battery will be less. The production cost of the 60,000 battery is more compared to that one. So production cost is also very important. So if the production cost is more, then the vehicle price will be more. Everything overall vehicle price will depend upon all these parameters. If the production cost is more, the correspondingly they will increase the price of the vehicle. So fourth one, lifespan. What is the lifespan of EV batteries? How much duration? How much years is going to run in an electric vehicle? ಎಷ್ಟು ವರ್ಷ ಕೊಡುತ್ತೆ ಒಂದು ಬ್ಯಾಟ್ರಿ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಅಲ್ಲಿ ಅಂದಾಜು
10 year.
10 years.
10 year.
Very good. Around 10 years. It may be varies from how we are going to use, how we are going to maintain the electric vehicle. It is in the range of about 10 years. You can say in the range it is about 8 to 13 to 14 years. Or in terms of distance also we can say in terms of distance it is around 1,50,000 to the 3 lakh. Up to 3 lakh is going to be, we can use the batteries. And the fourth one, recharging capacity. The recharging capacity is also very important one. How fast we are going to recharge the batteries, that is also one important thing. And the last one is the environmental impact. How it is going to affect the environment after the disposal. Once the disposal happens, it will be harm to the environment. How it is going to dispose, how it can be burn or whatever there is after the use of in the electric vehicle, how it can be used in other way. That is also very important thing. When we throw it outside after the use of the battery, it somewhere it may blast, it causes the pollution in the environment. It leads to some harmful gases into the environment. So environmental impact is also major concern we need to consider. So while selecting the batteries, these 6 parameters we need to consider: battery weight, storage capacity, production cost, lifespan, recharging capacity, and environmental impact. So these are the types of batteries what we have. So can you name the batteries here? Can you name the batteries that I have put in the slide?
Lead acid battery, nickel cadmium battery, lithium ion battery.
Then
Nickel metal hydride battery, solid state battery.
Okay, good. So these are the mainly 5 types of batteries that we use in the electric vehicle, from earlier days of invention of electric vehicle to the recent advancements in the electric vehicle. The first battery that we are using in electric vehicle is the lead acid battery. So the same thing what we use in the IC engine vehicle. Next one is the nickel cadmium battery, lithium ion battery, nickel metal hydride battery, and the last one is the solid state battery. All of you have one activity here. Can you specify the 3 different applications of each batteries? You go to your Google or ChatGPT or any AI assistant, search there, specify at least 2 to 3 or 2 applications of each battery. All of you. Salman, Rashmi, Mamta. It's a simple activity.
Sir, lead acid battery applications, automobiles, UPS system, ಮತ್ತೆ
All 5. You consider all 5. I will ask one by one. Lead acid, nickel cadmium, lithium ion, nickel metal hydride, and solid state. Because after the lunch all of we feel sleepy, that's why we give for an half hour an activity in between the classes, in between the lecturing, so that I and you also both in active in hearing and also delivering the lecture. applications of each battery, 5 different types of battery that what we are using in the electric vehicle. Salman. Mamta, Sneha.
Yes, sir. Lead acid battery, automobiles,
Hmm.
UPS,
UPS.
inverter,
Then nickel cadmium battery. Salman, can you specify the application of
emergency
nickel cadmium battery?
medical equipment, so emergency lightning system,
Okay.
backup power
Lithium
system,
ion battery.
lithium ion battery, EV, mobile phone, laptop, tabs.
Okay. Then nickel metal hydride battery.
Hybrid EV, digital cameras,
Very good.
medical equipment.
Then last one, the solid state battery.
ಲ್ಯಾಪ್ಟಾಪ್ ಸ್ಮಾರ್ಟ್ಫೋನ್ಸ್ EV ಸೆಲ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ.
Okay. Salman, are there? Salman, ಇದೇನಪ್ಪ? Okay, we'll go one by one. The first battery that we use in the electric vehicle is the lead acid battery. It is invented in the year 1859. So inventor is the Gaston Dante. He belongs to the country of France. This is the world's first rechargeable battery. Lead acid battery is the world's first rechargeable battery. Its applications here. Applications are early it was used in the electric vehicle, electric golf carts, electric forklifts, back power system of these systems, then auxiliary 12 volts battery model EVs also. So wherever 12 volt batteries are required, 12 volt applications are required, this battery is used in the electric vehicle nowadays also. The main advantages of lead acid battery: lowest cost, mature technology, easy to manufacture, highly recyclable, of about 95%, good surge current capability. The disadvantages is very weight, very heavy, that means very heavy, low, somebody has joined, I think. It is very heavy, low energy density, short cycle life, slow charging, and requires maintenance. Second one is the nickel cadmium battery. It is invented in the year 1899 by the inventor Waldemar Jagner. He belongs to the Sweden company, Sweden country. The voltage, cell voltage is 1.2 volts. These nickel cadmium batteries are used. This nickel cadmium hydroxide is used as a positive electrode, and cadmium is used as a negative electrode. Here we are not going to discuss about the operation construction of those things in the of the batteries. So only we are going to overview the which type of batteries are available in the market and what are the pros and cons, and the way we are going to use those uh, those batteries and which battery is suitable for the electric vehicle. Its applications are it's also used in the earlier electric vehicles in the aviation, railway signaling, emergency lighting, cordless tools. Advantages are long life cycle, high discharge current, operates in extreme temperatures, rugged and reliable. Disadvantages are cadmium is toxic, memory effect, low energy density and heavy. It is too heavy, that means weight of the battery is high. Environmental concern is the biggest one. Next, third one is the nickel metal hydride battery. It is invented in the year of 1989, developed by Ovonic Battery Company based on work led by Stanford Aviskai. Nickel metal hydride batteries replace toxic cadmium with hydrogen absorbing metal alloy, offering improved capacity and environmental performance. Its cell voltage is also has 1.2 volts. Applications is mainly this nickel metal hydride batteries are used in hybrid electric vehicles in the company Toyota Prius, electric buses, medical devices. Advantages are high energy density than the nickel cadmium batteries, environmentally safer, because as I said this nickel metal hydride is an environmental concern, one of the important parameter, this nickel cadmium, where it has an environmentally safer, long cycle life, reliable, good power output. Its disadvantages are higher self discharge, generates more heat, lower energy density than the lithium ion, and more expensive. The one of the important batteries, the battery that is used in electric vehicle nowadays, that is lithium ion battery. It is invented in the year of 1999 by Sony. Lithium ion batteries are dominant battery technology in modern electric vehicles because of the advantages like high energy density, low weight, fast charging capability, and long life. Its cell voltage is of about 3.6 to 3.7 volts, where the previous nickel cadmium nickel metal hydride batteries have the cell voltage of 1.2 volts only. Compared to those batteries, lithium ion battery cell voltage is much higher, that is of about 3.6 to 3.7 volts. The main applications of these lithium ion batteries, one of the important application is battery electric vehicle, that what we call simply electric vehicle. Like in hybrid electric vehicles also, electric two-wheelers, electric buses, energy storage systems. Advantages, one of the biggest advantage of lithium ion batteries of higher energy density, lightweight, fast charging, high efficiency, low self discharge, and long cycle life. It has also disadvantage. It is expensive, the cost is high compared to those batteries. Required battery management system to monitor the voltage, current, and different parameters of the battery system. Thermal runaway risk is damaged, so sensitive to overcharging. These are the disadvantages of lithium ion battery. There are 5 different types of lithium batteries: lithium iron phosphate, lithium titanate, lithium nickel manganese cobalt, lithium manganese oxide, lithium nickel cobalt aluminum oxide. So these are the different 4 types. The 5th one is the solid state battery. It has nowadays work is going on these batteries to implement in the electric vehicle. So previously those batteries are using the liquid electrolyte, where solid state battery they have used the solid electrolyte. So these 4 batteries what we have discussed now, lithium ion battery, nickel metal hydride, nickel cadmium, and lead acid batteries. These 4 batteries use the liquid electrolyte. But this one is since this solid state battery uses the solid electrolyte to improve the safety and potentially increasing the energy density. Applications in future it might be used in the electric vehicle for high performance, and also may be used in the aerospace. It is also called as next generation energy storage element. Advantages: very high energy density compared to all the four batteries that what we have discussed. Improved safety is a major concern. Fast charging potential, lifelong lifespan, reduced fire risk. Disadvantages are very expensive, difficult to manufacture, limited commercial availability. Technology is still maturing because the work is going on, research is going on these batteries. So you have the case study here. See the slide, read carefully. Battery selection for an electric vehicle. Title becomes selecting the most suitable battery for a new electric vehicle. Scenario: an automobile company is designing a compact electric car with the following requirements: range 250 km, top speed 100 km per hour, budget moderate battery life, moderate battery life at least 8 years. It should be fast charging capability. Preferred task: compare lead acid, nickel, metal hydride and lithium ion batteries. Recommend the most suitable battery and justify your choice. Explain why other battery types are not preferred. Discuss the expected battery lifespan and factors affecting it. Before this one, you have the simple formula for finding the battery capacity. This is the thumb rule that we are going to follow to find out the battery capacity of the battery. So the required battery capacity can be estimated using battery capacity in kilowatt hour equal to energy consumption watt hour per kilometer into desired range in terms of kilometer divided by 1000. Take this formula. Take the formula. Battery capacity equal to energy consumption in terms of watt hour per kilometer, desired range divided by 1000. I think all of you have taken this. A simple example when we consider capacity of battery required. If the desired range is 300 km, energy consumption is 150 watt hour per kilometer, then battery capacity is 150 into 300. Use the formula, this formula. 150 to 300 divided by 1000, it is a 45 kilowatt hour. What is desired range? I think I asked you in the yesterday class. Once again, what is desired range? What is desired range? Uday? ಯಾಕಪ್ಪ ಲೇಟ್ ಆಯ್ತು?
ಸರ್ ಕಾಲೇಜಲ್ಲಿ ಸರ್
ಕಾಲೇಜಲ್ಲಿ ಲೇಟ್ ಆಯ್ತಾ?
ಹಾಂ ಸರ್, ಇಂಡಕ್ಷನ್ ಪ್ರೋಗ್ರಾಮ್ ಎಂಡಿಂಗ್ ಪ್ರೋಗ್ರಾಮ್ ಇತ್ತು ಸರ್, ಹಂಗಾಗಿ ನೋಡಿದ್ದಿಲ್ಲ ಸರ್, ನಾನು ಇವಾಗ ನೋಡಿದೆ ಸರ್ ಮೆಸೇಜ್, ಹಂಗಾಗಿ. ಹಾಂ ಸರ್, ಫುಲ್ ಇವತ್ತು ಲಾಸ್ಟ್ ಡೇ ಸರ್ ಡಿಪ್ಲೊಮಾ ಕಾಲೇಜ್ ಇಂಡಕ್ಷನ್ ಫಂಕ್ಷನ್, ಹಂಗಾಗಿ 4 ಡೇಸ್. ಹಾಂ ಸರ್, 1 to 4 ನಾ ಮಂಡೆಯಿಂದ ಕ್ಲಾಸಸ್ ಸ್ಟಾರ್ಟ್ ಸರ್. sir.
What is desired range? Desired range is nothing but once battery is completely fully charged, how much distance it can run, the vehicle can run is till battery is completely discharged. Once it full charge ಆದಮೇಲೆ ಎಷ್ಟು ದೂರ ನಾವು ವೆಹಿಕಲ್ ನ ಡ್ರೈವ್ ಮಾಡಬಹುದು, that is nothing but the desired range. So here the desired range is 300 km. That means once battery is completely charged, it can run for 300 kilometers. Energy consumption is 150 watt hour per kilometer. Means 1 kilometer run ಆಗಲಿಕ್ಕೆ 150 watt hour ಅಷ್ಟು ಎನರ್ಜಿ ಕನ್ಸ್ಯೂಮ್ ಆಗುತ್ತೆ. 150 watt hour ಅಷ್ಟು, that means 0.15 kilowatt. 150 watt hour 1 per kilometer. Then the capacity of the battery requirement is, using this formula, energy consumption is 150 watt hour per kilometer, that is 150 into desired range. Desired range is 300 kilometers divided by 1000 is 45 kilowatt hour. So for the running a 300 kilometer distance or completely charged, a battery required is 445 kilowatt hour. In the same way, second example is, if the desired range is 500 kilometer, energy consumption is 180 watt hour per kilometer, then the battery capacity is 90 kilowatt hour battery. So by seeing these two examples, what you can conclude by looking at these two examples? Sneha? Sneha? By looking at these two examples, what you can conclude? What information we get?
ಸರ್ ಅದರಲ್ಲಿ ಹೈಯರ್ ರೇಂಜ್ ಇದ್ದು ಮೋರ್ ಕೆಪಾಸಿಟಿ ಇದಾಗುತ್ತೆ ಸರ್.
Okay. If the distance is
ಮತ್ತೆ
desired range is more, then the battery capacity should be more. See, in the first example, desired range is 300 kilometer, battery capacity is 45 kilowatt hour. In the example 2, desired range is 500 kilometers, it is more than 300 kilometers, then the battery requirement is 90 kilowatt hour. So if the desired range is more, then the capacity of the battery requirement is also more. Now we have the activity, previously I said this one, case study, how we select the battery for electrical car. If you are an engineer, if somebody gives the specifications of range is 250 km, speed is 100 km per hour, budget should be moderate, it should not be too high. If we consider the budget is very low, then the quality of the battery will be poor. So that's why it should not be too high, it should be moderate, and our battery lifespan should be at least 8 years, and it should be fast charging. So what we have to do? First, compare for the above data lead acid, nickel metal hydride and lithium ion batteries. Recommend the most suitable battery. ಯಾವ ಬ್ಯಾಟರಿಯಲ್ಲಿ lead acid better, above dataಗೆ lead acid better, nickel metal hydride better, ಅಥವಾ lithium ion battery. Justify your choice. Why you are going for, if your answer is lead acid battery, then what is your answer? How can you justify lead acid battery is the best one? If your answer is nickel metal hydride, you need to justify why. If your answer is lithium ion battery, you need to justify why. Then explain why the other battery types are not preferred. ಯಾಕೆ lead acid battery prefer ಮಾಡ್ತೀರಾ? Why not nickel metal hydride and lithium ion battery? You need to explain. And also finally discuss the expected battery lifespan and factors affecting it. These 4 points you need to take down for the data given. The scenario is an automobile company is designing a compact electric car with the following requirements. When the electric company ಆಟೋಮೊಬೈಲ್ ಕಂಪ್ನಿ ಈ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಇಟ್ಕೊಂಡು ಒಂದು ಬ್ಯಾಟ್ರಿ ಡಿಸೈನ್ ಮಾಡ್ತಾ ಇದೆ. ವಿಚ್ ಬ್ಯಾಟ್ರಿ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಪ್ರಿಫರ್? ನೀವು ಕಂಪ್ನಿಗೆ ಯಾವ ಬ್ಯಾಟ್ರಿ ಪ್ರಿಫರ್ ಮಾಡಬೇಕಂತ ನೀವು ಹೇಳ್ತೀರಾ. ಆ್ಯಂಡ್ ನಾಟ್ ಓನ್ಲಿ ಯು ನೀಡ್ ಟು ಸೇ ದಿಸ್ ಬ್ಯಾಟ್ರಿ ಇಸ್ ಪ್ರಿಫರಬಲ್ ಆ್ಯಂಡ್ ಯು ನೀಡ್ ಟು ಜಸ್ಟಿಫೈ ವೈ. ಓಕೆ, ವಿಲ್ ಹ್ಯಾವ್ ಸಮ್ ಟೈಮ್. You go through the, you can use your Google or any AI assistant, you come up with an answers.
It will be preferred lithium-ion battery, sir.
Oh, not just only by telling you the lithium ion battery is nowadays using, you need to justify your answer.
Yeah, sir.
Not only what I have learned, what I have taught from the previous slides, you need to work on that one. The study, case study is not only an immediate answer. You should work on something. You should work.
Yes, sir. Previous model we already studied it, sir. Lead acid battery, lithium-ion battery. So that based I will tell you.
Okay.
Yeah, lithium-ion battery higher density, energy density is there, sir. So it like ranging from 150 to 250 watt hour kg. Compared to these two batteries like lead acid batteries and nickel metal hydride batteries.
Okay.
And it is also lifespan is very excellent
Excellent.
for lithium ion battery compared to these two batteries.
Okay.
And it is a lightweight for these two batteries compared. Sir. And it
What is
is
the weight of the
more
see,
lifespan compared to these two.
I have a question. What is the weight of the battery, lithium battery, for 250 km with a speed of 100 km per hour? What is the weight of the battery, weight of the lead acid battery for 250 km and a speed of 100 km per hour? What is the weight of the nickel metal hydride for 250 km and a speed of 100 km per hour? So like that, with the statistical analysis you need to justify. Clear?
Sir.
Okay. You justify in terms of cost and in terms of weight. That's more than enough. I think all of you are working on this.
Yes, sir.
Over.
Sir.
Sneha.
यस सर.
ಆಯ್ತಾ?
ಹಾಂ ಸರ್.
ಮಮತಾ
ಸರ್.
ಮಮತಾ ಇಲ್ಲ.
ಇಲ್ಲ ಸರ್.
ಸಲ್ಮಾನ್ ಸಲ್ಮಾನ್ Okay, Sneha. What's your discussion points? Have you noted the points discussed here?
Yes, sir.
Okay, tell me.
Uh, First, for the range of 250 kilometer to 250 kilometer of range, and for the speed of 100 kilometer per hour, we will prefer lithium ion batteries. Why? Because it has a high energy density, and the weight of the lithium ion battery is very less compared to others. So, we will prefer lithium ion battery, and it is most durable. So, we will prefer a lithium ion battery. Uh, Coming to the other batteries, lead acid batteries will be very heavier, and it will reduces the efficiency of the system. So we will not prefer a lead acid battery for this range.
Okay.
And for nickel metal hydride, we will not prefer this because of low energy density.
Okay.
And this nickel metal hydride also very heavier, and it is very costlier. So
Okay.
will not prefer this for moderate budget of the battery.
Okay.
uh, Next is the factors affecting the battery's lifespan, as we have discussed in the first of the class. It is a weight of, we will consider a weight of a battery, cost for the management of the battery, and storage capacity, production cost, lifespan, recharging capacity, and environmental impacts.
Okay. This is the factors we need to consider.
Yes, sir.
Okay. Good. Then, what is the energy density of lead acid battery?
Energy density of lead acid battery.
As we said, energy density of lead acid battery is less, so it is of about 30 to 50 watt hour per
Yes,
kg.
30 to 60, I think,
60.
sir.
In lithium battery has the capacity of energy density 150 to 250 watt hour per. So that's why we say lithium ion battery is a much higher energy density compared to the lead acid battery
Lead
and
acid.
other batteries. Okay, very good.
Yes.
Then Achar, Uday.
Sir, yes, sir.
Okay, tell me, what's your justification?
So why we are selecting from lithium ion battery, sir? So I will prefer for only lithium ion battery.
Okay.
So already told, sir.
Mm.
So weight I have already weight and cost compared these two things.
These two things. Okay.
Lithium ion battery packs weight only 200 to 300 kilograms. So keeping the car light allows it will be easily eat for 100 kilometer per hour,
Okay.
like top speed,
Top
and it
speed.
will be traveling from 250 kilometers on single charger.
Single charges. Okay, good.
Yes, sir. And compared to cost advantage, while the initial purchase of price is higher, sir, last over of 8 years, why we will not to need to buy the replacement of the battery, and it will be making it to most cost effective option for moderate budget.
Okay.
Sir.
Very good.
So,
For all these parameters, if you consider, lithium ion battery is the one of the best battery that we can choose for the electric vehicle. Okay, good. So this is a comparison that we have. So you also gone through these parameters when you are searching for the case study. Initially, as mentioned, cell voltage of lead acid battery is 2 volts, and that of nickel cadmium is 1.2. Nickel metal hydride is 1.2 volts, same thing. Lithium ion is 3.6 to 3.7, where solid state is the cell voltage of 3 to 4 volts. The energy density is high in the lithium ion battery, but what we have emerging technology, emerging battery that research is going on solid state batteries have very high energy density compared to lithium ion itself. Life cycle also still till now lithium ion battery is good, but solid state is very much high than the lithium ion. Cost, as the more advantages, lithium ion battery is a high cost compared to the remaining three. and typical EV applications in the earlier days, lead acid batteries, nickel cadmium batteries are using. Nickel metal halide batteries are used in the hybrid electric vehicles. In most of the electric vehicles in the recent manufacturing companies, they are going for the lithium batteries. But may be sure, the solid state batteries are the future concern for the electric vehicle. So with all these things, presently lithium ion battery is the one which is used in most of the manufacturing EV manufacturers. But in the future, they have the long term goal. There is another battery of the future that is nothing but solid state batteries, which have cell voltage of higher than the other batteries. Energy density is also very high compared to remaining 4 batteries. Life cycles is also high. Cost is obviously should be high, as these all things are high, then cost is also high. So they are considered as the futures of electric vehicle. This is about the batteries. So this is the picture. It shows the battery package where you are going to place the in the electric vehicle. There is series and parallel combination. This is the one unit. Together these units are placed here in this fashion. This is already we have taken. This is simple problems we considered. So this is the table that gives typical battery capacity, motor power rating, and driving range of electric vehicles. So this is the standard one. The first column represents the vehicle type, second one is the typical motor power, and the corresponding battery capacity that we need to have for the electric vehicle. And if you consider these two, what is the driving range of that battery is also given here. See, we will look into these values. Scooter typically it uses 1 to 5 kilowatt motor. Battery capacity is 2 to 5 kilowatt hour. Driving range is 60 to 150 kilometer. And electric motorcycle, power rating of the motor is 5 to 20 kilowatt. Battery capacity is 4 to 10 kilowatt hour, and driving range is 100 to 250. Electric car, it has a motor capacity of 50 to 150. Battery capacity is 30 to 80 kilowatt hour, and driving range is 250 to 600. Electric SUV model, motor capacity is 100 to 250. Battery capacity is 60 to 120. Driving range is 400 to 650. Electric bus, motor capacity is 150 to 350. Battery capacity is 200 to 500 kilowatt hour, and typical range is 150 to 400 kilometer. Bigger one, that is electric truck, it should be obviously a motor capacity should be higher, for about 300 to 300 kilowatt hour. Battery capacity is 300 to 800 kilowatt hour, and typical driving range is 250 to 600. So as the power rating from this table you can conclude, as the power rating is high, battery capacity is high. As the battery capacity is high, driving range is also high. ಏನಂತ ಸಿಂಪಲ್ ಆಗಿ ಹೇಳೋದಾದ್ರೆ, ನಾವು ಐಸಿ ಪೆಟ್ರೋಲ್ ಗಾಡಿ ಬೈಕ್ ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ, ಬೈಕಲ್ಲಿ ಜಾಸ್ತಿ ಪೆಟ್ರೋಲ್ ಇದ್ದರೆ ಜಾಸ್ತಿ ದೂರ ರನ್ ಮಾಡ್ತೀವಿ. ಬೈಕಲ್ಲಿ ಪೆಟ್ರೋಲ್ ಕಡಿಮೆ ಇದ್ದರೆ ಹೋಗೋ ದೂರ ಕಡಿಮೆ ಆಗುತ್ತೆ ಅಷ್ಟೇ. ಅದೇ ರೀತಿನೇ ಬ್ಯಾಟ್ರಿ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಇದ್ದರೆ ಜಾಸ್ತಿ ದೂರ ಹೋಗ್ಬೋದು ಒಂದ್ಸಲಿ ಫುಲ್ ಚಾರ್ಜ್ ಆದ್ಮೇಲೆ. ಅದೇ ಬ್ಯಾಟ್ರಿ ಕೆಪಾಸಿಟಿ ಕಡಿಮೆ ಇದ್ದರೆ ಕಡಿಮೆ ದೂರ ಹೋಗ್ಬೋದು. ಅದೇ ರೀತಿನೇ ಬ್ಯಾಟ್ರಿ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ, ಪವರ್ ರೇಟಿಂಗ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದರೆ ಬ್ಯಾಟ್ರಿ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಇರಬೇಕು. ಪವರ್ ರೇಟಿಂಗ್ ಕಡಿಮೆ ಇದೆ ಅಂದರೆ ಬ್ಯಾಟ್ರಿ ಕೆಪಾಸಿಟಿ ಕಡಿಮೆ ಇರಬೇಕು. ಅಂದರೆ ವೇಟ್ ಆಫ್ ದ ವೆಹಿಕಲ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದರೆ ಆಬ್ವಿಯಸ್ಲಿ ಬ್ಯಾಟರಿ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಬೇಕು. ವೇಟ್ ಆಫ್ ದ ವೆಹಿಕಲ್ ಕಡಿಮೆ ಇದೆ ಅಂದರೆ ಬ್ಯಾಟರಿ ಕೆಪಾಸಿಟಿ ಕಡಿಮೆ ಇರಬೇಕು. ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ ಪವರ್ ಇನ್ ಜನರಲ್ ಮೀನಿಂಗ್. So now we are moving to the last concept. So last but one, performance characteristics of electric vehicle. The performance characteristics of electric vehicle describe how well it operates under different driving conditions. The key characteristics are performance characteristics of an electric vehicle. In generally ಹೇಳೋದಾದ್ರೆ, for example, performance characteristics of Uday Achar. Performance characteristics of Uday Achar ಹೇಳೋದಾದ್ರೆ ಅರ್ಥ ಏನು? How it is, ಯಾವ ರೀತಿ ಅವನು 1 hour ಕ್ಲಾಸಲ್ಲಿ ಕೂತ್ಕೊಳ್ಳೋಕೆ ಕೇಪಬಲ್ ಇದೆನೋ, ಅಥವಾ 1.5 hour ಕೂತ್ಕೊಂಡ ಕ್ಲಾಸಲ್ಲಿ, ಅಥವಾ 2 hours ವರೆಗೂ ಕೂತ್ಕೊಂಡ, ಅಥವಾ ಒಂದು ಕಾನ್ಸೆಪ್ಟ್ ನ ಎಷ್ಟು ಬೇಗ ಅರ್ಥ ಮಾಡ್ಕೊಂತಾನೆ ಕಂಪೇರ್ ಟು 5 members, how fast is going to understand the concept what we are going to tell. So those are the parameters that measures the performance of any person. ಹೌದಾ? ಎಷ್ಟು ಫಾಸ್ಟ್ ಓಡ್ತಾನೆ, ಎಷ್ಟು ಚಪಾತಿ ಅವನು ತಿಂತಾನೆ, ಎಷ್ಟು ಊಟ ಅವನು ಮಾಡ್ತಾನೆ, ಎಷ್ಟು ತೂಕ ಅವನು ಎತ್ತಾನೆ. So those are the performance parameters of the person. So in the same way, performance parameters of the electric vehicle also should use under different driving conditions. It describes how well it operates under different driving conditions. The main characteristics are driving range, obviously the first point what we discussed, that is the driving range, then maximum speed, then acceleration, then gradability, then energy consumption, efficiency, regenerative braking, charging time, and battery performance. We go one by one. The first one is the range. Remember the range, maximum speed, acceleration, gradability, energy consumption, efficiency, regenerative braking, charging time, and battery performance. What is driving range? As we already discussed. What is maximum speed? That is the highest speed of any electric vehicle that can achieve. Maximum speed, if the economy of the speed is of about 80 to 120, ಅಂದರೆ mileage ಆ ಪಾಯಿಂಟ್ ಆ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ರನ್ ಮಾಡಿದ್ರೆ we get the good mileage ಅಂತ ಹೇಳ್ತೀವಿ. So but the maximum speed is at what highest speed of an electric vehicle that can achieve or that can reach. For any vehicle it may be 150 or 160 or 130 depending upon the capacity, motor rating and torque rating of the motor. Second one is, third one is acceleration. What is acceleration? As I said in the last class, how quickly electric vehicle increases its speed. That is the acceleration. Increases its speed means is nothing but from 0 to 100 kilometer per hour. And means 0 to 100 kilometer per hour ಅಷ್ಟು ಸಡನ್ ಆಗಿ ರೈಸ್ ಆಗೋಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ? ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ಆಕ್ಸಲರೇಷನ್. ಕೆಲವೊಂದು 8 seconds ಅಲ್ಲಿ ರೀಚ್ ಆಗ್ತವೆ, ಕೆಲವೊಂದು ವೆಹಿಕಲ್ 4 seconds ಅಲ್ಲಿ ರೀಚ್ ಆಗ್ತವೆ, ಕೆಲವೊಂದು ವೆಹಿಕಲ್ 10 seconds ಅಲ್ಲಿ ರೀಚ್ ಆಗ್ತವೆ. ದಟ್ ಶೋಸ್ ದ definition of acceleration for particularly for the electric vehicle. And gradability. Gradability is nothing but the ability of the electric vehicle to climb slope and hills. It usually expresses in terms of percentage. So 20-degree slope alidre 20-degree slope alidre performance ಯಾವ ರೀತಿ ಇರುತ್ತೆ, 25-degree slope alidre performance ಯಾವ ರೀತಿ ಇರುತ್ತೆ, 30-degree alidre performance ಯಾವ ರೀತಿ ಇರುತ್ತೆ, 45-degree alidre ಸಾಧ್ಯ ನಮ್ಮ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ರನ್ ಆಗಲಿಕ್ಕೆ. Gradability is some normal condition that standard degree is there from 0 to 20 degree. If it exceeds, something may happen. It may be 25, 30 degree or 40 degree or 50 degree. If the theta goes on increases, the slope is also goes on increases. If the slope is almost become 70 degree, 70 even 50 degree, the vehicle will fall down. So that degree we need to calculate, which is the specific degree that the driver can run the vehicle safely. So that is the gradability. Then energy consumption. This is nothing but the amount of electrical energy consumed per unit distance. It is so standardly it is represented in terms of kilowatt hour per 100 kilometer or watt hour in terms of watt hour per kilometer. If it is kilowatt hour, then it should be in terms of 100 kilometer. If it is watt hour, it is in terms of kilometer. Then the efficiency should be high. Almost electrical vehicle has an efficiency of 80 to 90%. Then the regenerative braking, it is the ability to recover kinetic energy during braking condition. So regenerative braking appears only during the braking condition. It is the ability of that vehicle to recover kinetic energy. That is the regenerative braking performance. And then the charging time, how much time is going to be charged. The most research is going on this one. How fast we can charge the battery. That is the main thing. That is also one of the important parameters that can be defined under performance characteristics. And the last one is the battery performance. How as we discussed earlier, battery, the lifespan and the environmental condition and how fast it is going to be charged. These are all the performance we can take into consideration. That is nothing but the battery performance. One by one we go with, there are different graphs that we have for each characteristics. The first one, driving range of an electric vehicle. See the graph. See the graph carefully. What it says, the graph from the, what you can know from the graph, it is the driving range versus battery capacity. Means for a particular battery, if it is completely charged, how distance it vehicle can run. That shows the graph, that shows the characteristics of the electric vehicle, driving range in kilometer versus battery capacity. As we know, as we discussed in the last slide, if the battery capacity is high, driving range is also high. So if the battery capacity is low, driving range is also low. See the graph what we have here. See, battery capacity is 2 to 5 kilowatt hour, then the driving range is 60 to 150. If the battery capacity is 300 to 800, it is much more increased. Here the driving capacity is also very high, it is 250 to 600 kilometer. So the relation between battery capacity and the driving range is linear, so that's why this is the curve. As the battery capacity increases from 0 to 120, the driving range is also increases from 0 to 600. So for the 100 kilowatt hour, the driving range corresponding driving range is about 510 kilometer. So driving range is the formula, usable battery energy in terms of kilowatt hour divided by energy consumption in terms of kilowatt hour per kilometer. We have given the simple example for here that to calculate the driving range. if the usable battery energy is 60 kilowatt hour, then the energy consumption is 0.15 kilowatt hour per kilometer, then the driving range is 400 kilometer, because driving range is usable battery energy divided by energy consumption. So that is 60 divided by 0.15, it gives 400 kilometer. That means if the battery has a capacity of 60 kilowatt hour, then with the fully charged, that electric vehicle run for 400 kilometers. After again 400 kilometers, we need to charge the battery. This is the what we can conclude from the characteristics of driving range with respect to battery capacity. One thing you remember, the single way, if the battery capacity is high, driving range is also high. That's the slope is, that's the characteristics is in linear. See, the range increases with the battery capacity, but at a decreased rate. What it mean by decreased rate? Here we said in the graph, in the black boxes, range increases with the battery capacity, that's okay. But at decreased rate, what it mean? Decreased rate means, see, if the battery capacity is 20, the corresponding, if we draw the line, vertical line from the 20, from the x-axis to the slope, at 20 kilowatt hour, the driving range is of about 120. ಹೌದಾ? ಗೊತ್ತಾಗ್ತಾ ಇದೆನಾ? ಕರ್ಸರ್ ಕಾಣ್ತಾ ಇದೆಯಲ್ಲ?
Yes, sir. Yes.
If the battery capacity is 20, the corresponding driving range is of about 120 kilometers. So now 20 is multiplied by 5. For example, 100. Come to 100. 20 is multiplied by 5 is come to 100. At 100, it is multiplied by 5. So ಇಲ್ಲಿ 110 120 multiplied by 5 ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ ನಮಗೆ? 110 multiplied by 5 ಮಾಡಿದರೆ ಆಲ್ಮೋಸ್ಟ್ 600 ಬರಬೇಕು. ಬಟ್ ಎಷ್ಟು ಬರ್ತದೆ ನಮಗೆ 100 ಗೆ almost we are getting the 500. So as battery capacity increases, driving range increases, but at reduced rate, ಅಂದರೆ ಸೇಮ್ ರೇಟ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಆಕಂತ ಹೋಗೋದಿಲ್ಲ. ಅಂದರೆ ಇದು 5 ಟೈಮ್ಸ್ ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಬ್ಯಾಟರಿ ಕೆಪಾಸಿಟಿ, ಡ್ರೈವಿಂಗ್ ರೇಂಜ್ ಕೂಡ 5 ಟೈಮ್ಸ್ ಜಾಸ್ತಿ ಆಗಲ್ಲ. ಸೊ ಸ್ವಲ್ಪ ಕಡಿಮೆ ಇರುತ್ತೆ. ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ದ ರಿಡ್ಯೂಸ್ಡ್ ರೇಟ್ ಅಂತ. ಈಗ 2 ಟೈಮ್ಸ್ ಇನ್ ಬ್ಯಾಟರಿ ಕೆಪಾಸಿಟಿ ಡಬಲ್ ಮಾಡಿದ್ರೆ ಡ್ರೈವಿಂಗ್ ರೇಂಜ್ ಡಬಲ್ ಆದರೆ ಪ್ರಪೋರ್ಷನಲಿ ಅಂತ ಹೇಳ್ಬೋದು. ಬ್ಯಾಟರಿ ಕೆಪಾಸಿಟಿ ಡಬಲ್ ಮಾಡಿ ಡ್ರೈವಿಂಗ್ ರೇಂಜ್ ಡಬಲ್ ಗಿಂತ ಕಡಿಮೆ ಆದರೆ ದೆನ್ ಇಟ್ ಇಸ್ ಅಟ್ ಡಿಕ್ರೀಸ್ ರೇಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಕೀ ಪಾಯಿಂಟ್ಸ್ ಏನು ಹೇಳ್ಬೋದು? Range increases as battery capacity increases. The increase in range becomes smaller at high battery capacities, that is at decreasing rate. Actual range depends on energy consumption and driving conditions. Always, for example, ನಿಮ್ಮ ಕಾರು NH4 ಅಲ್ಲಿ ಹೋಗಬೇಕಾದ್ರೆ ಒಂದ್ಸಲಿ ಫುಲ್ ಚಾರ್ಜ್ ಆಗೋದ್ರೆ 400 ಕಿಲೋಮೀಟರ್ ಕೊಡ್ತಾ ಇದೆ ಅನ್ಕೊಳ್ಳಿ. ಅದೇ 400 ಕಿಲೋಮೀಟರ್ ಕೊಡೋದು ಅದೇ ಕಾರ್ನ ಫುಲ್ ಚಾರ್ಜ್ ಮಾಡಿ ಬೆಂಗಳೂರಿನ ಸಿಟಿಯಲ್ಲಿ ಓಡಿಸಿದ್ರೆ 400 ಕಿಲೋಮೀಟರ್ ಕೊಡುತ್ತಾ? ಇಲ್ಲ. ಸೊ ಅದೇ ರೀತಿನೇ ಎಕ್ಸಾಂಪಲ್ ನಾವು ಸಿಮಿಲರ್ ಎಕ್ಸಾಂಪಲ್ ಅನಲಾಗಿ ಪೆಟ್ರೋಲ್ ಬೈಕ್ ಕಾರ್ ತಗೋಬಹುದು. ಪೆಟ್ರೋಲ್ ಕಾರು ಹೈವೇದಲ್ಲಿ ನಿಮ್ಗೆ 17-18 ಕಿಲೋಮೀಟರ್ ಪರ್ ಲೀಟರ್ ಕೊಟ್ರೆ ಅದೇ ನೀವು ಸಿಟಿಯಲ್ಲಿ ಓಡಿದಾಗ ಅದೇ ಬರುತ್ತೆ 10-12 ಬರುತ್ತೆ. ಸೊ ಇಟ್ಸ್ ಆಲ್ವೇಸ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ವೇರ್ ವಿ ಆರ್ ಡ್ರೈವಿಂಗ್, ವೆದರ್ ಇನ್ ದ ಫ್ಲಾಟ್ ಆರ್ ಇನ್ ದ ಹಿಲ್ಸ್ ಏರಿಯಾ ಆರ್ ಇನ್ ದ ಅರ್ಬನ್ ಏರಿಯಾ. ಇಟ್ಸ್ ಆಲ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದಟ್ ಒನ್. ಆಲ್ವೇಸ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಎ ಕಾನ್ಸ್ಟೆಂಟ್. ವಿ ಶುಡ್ ಗೆಟ್ ದ ಕಾನ್ಸ್ಟೆಂಟ್ ಡ್ರೈವಿಂಗ್ ರೇಂಜ್. So the temperature, speed, terrain, payload and driving style significantly affect the range. These are the different parameters significantly affect the range, driving range. ನಾವು ನಾರ್ಮಲ್ ರೋಡ್ ಒಳಗೆ ಒಂದು ರೇಂಜ್ ಬರಬಹುದು, ಮೈಲೇಜ್ ಬರ್ಬೋದು, ಸಿಟಿಯಲ್ಲಿ ಒಂಥರ ಮೈಲೇಜ್ ಬರ್ಬೋದು, ಇಲ್ಲಿ ಏರಿಯಾದಲ್ಲಿ ಒಂಥರ ಮೈಲೇಜ್ ಬರ್ಬೋದು, ಸಿಂಗಲ್ ರೋಡ್ ಇದ್ರೆ ಒಂಥರ ಮೈಲೇಜ್ ಬರ್ಬೋದು, ಡಬಲ್ ರೋಡಲ್ಲಿ ಹೊಡಿಬೇಕಾದ್ರೆ ಒಂಥರ ಮೈಲೇಜ್ ಬರ್ಬೋದು. ಇಟ್ಸ್ ಆಲ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದೀಸ್ ಥಿಂಗ್ಸ್. ಸೊ ಟೆಂಪರೇಚರ್ ಯಾವ ಸ್ಪೀಡಲ್ಲಿ ಹೊಡಿತೀವಿ ಅನ್ನೋದು ಬರ್ಬೋದು. ನೀವು ಎರಡನೇ ಗೇರ್ ಹಾಕೊಂಡು 20-30 ಕಿಲೋಮೀಟರ್ ಹೊಡೆದಪ್ಪ ಅಂದರೆ ಮೈಲೇಜ್ ಕಡಿಮೆ ಬರುತ್ತೆ. ಅದೇ ನೀವು ಎಕಾನಮಿ ರೇಂಜ್ ಏನು ಬಂದ್ಬಿಟ್ಟು ಎವ್ರಿ ಕಾರ್ ಇಸ್ ಡಿಫೈನ್ಡ್ ಇಟ್ಸ್ ಎಕಾನಮಿ ರೇಂಜ್ ಆಫ್ ಅಬೌಟ್ 80 to 120 ಕಿಲೋಮೀಟರ್ or 80 to 100 kilometer. If it exceeds beyond 120 kilometer, again the mileage is going to be drop. So these specifications will be defined in all the specification sheet of the manufacturer car. So here also same thing you defined: factors affecting the driving range, battery capacity, energy consumption, driving condition, ambient temperature, vehicle load and driving style, auxiliary loads. ಈಗ ನಾನು ಕಾರ್ ಹೊಡಿತೀನಿ, ನಾನು ಕಾರ್ ಒಳಗೆ ಮೈಲೇಜ್ ಒಂದು 18 ಕಿಲೋಮೀಟರ್ ಬಂದರೆ ಸಲ್ಮಾನ್ ಕಾರ್ ಒಳಗೆ 17 ಬರ್ಬೋದು, ಉದಯ್ ಕಾರ್ ಒಳಗೆ 15 ಬರ್ಬೋದು. ಸೊ ಇಟ್ಸ್ ಅಪಾನ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ದ ಡ್ರೈವಿಂಗ್ ಸ್ಟೈಲ್. ಯಾರ ಕಾರ್ ಹೊಡಿತಾರೋ ಅವ್ರ ಸ್ಟೈಲ್ ಯಾವ ರೀತಿ ಇರುತ್ತೋ ಇಟ್ಸ್ ಅಗೇನ್ ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್. ಒಬ್ಬರು ಕಾರಲ್ಲಿ ಒಬ್ಬರಿಗೆ ಮೈಲೇಜ್ ವೇರಿಯೇಷನ್ ಆಗುತ್ತೆ, ಕಾರಲ್ಲಿ 4 ಜನ ಇದ್ರೆ ಮೈಲೇಜ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ಸ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ವೆಹಿಕಲ್ ಲೋಡ್. So finally, driving range is mainly determined by usable battery energy and energy consumption. For a given vehicle, reducing energy consumption or increasing battery capacity will increase the driving range. So battery capacity ಜಾಸ್ತಿ ಮಾಡಿದಂಗೆ driving range ಜಾಸ್ತಿ ಆಗುತ್ತೆ ಅನ್ನೋದು ನೆನಪಿಟ್ಟುಕೊಳ್ಳಿ. This is the final statement for the characteristics of the driving range of an electric vehicle. That is driving range versus battery capacity. It's all what we are telling. Battery complete charge ಆಗಿರಬೇಕು ಅನ್ನೋದು ಮನಸ್ಸಿಗೆ ಇಟ್ಕೊಂಡೆ we are explaining everything here. ಮತ್ತೆ ಬ್ಯಾಟರಿ 50% to 70% ಚಾರ್ಜ್ ಆಗಿರಂಗಿಲ್ಲ, ಫುಲ್ ಚಾರ್ಜ್ ಆಗಿರಬೇಕು. Second one, speed characteristics of an electric vehicle. The speed characteristics of an electric vehicle, the characteristics are drawn with power in terms of kilowatt hour versus vehicle speed in terms of kilometer per hour. Look into the graph or characteristics. Okay, this is speed characteristics of an electric vehicle. Speed characteristic shows how the available motor power and road power vary with vehicle speed. ಇಲ್ಲಿ ಎರಡು ಪವರ್ ತೋರಿಸಿದ್ದೀವಿ. along the x axis vehicle speed represent ಮಾಡಿದ್ವಿ, y axis ಅಲ್ಲಿ ಪವರ್ in terms of kilowatt ಹೇಳಿದ್ವಿ. ಈ ಬ್ಲೂ ಲೈನ್ ಇದೆಯಲ್ಲ, this line represents the motor power. ಗೊತ್ತಾಗ್ತದೆ, ಮೋಟರ್ ಪವರ್. there are two different powers. One motor power, ಇನ್ನೊಂದು power required to move the vehicle. ಎರಡು ಇದೆ ನೆನಪಿರಲಿ, ಎರಡು ಬೇರೆ ಬೇರೆ. ಯಾವ ರೀತಿ ಟಾರ್ಕ್ ಬೇರೆ ಬೇರೆ ಆಗುತ್ತೋ, ಟಾರ್ಕ್ ಅಂದರೆ ಮೋಟರ್ ಟಾರ್ಕ್ ಒಂದಿದೆ, ಒಂದು ವಿ ಟಾರ್ಕ್ ಅಂತದೆ, ಎರಡು ಡಿಫರೆಂಟ್ ಹೇಳ್ತಾರೆ. ಅದೇ ರೀತಿಯಲ್ಲಿ ಮೋಟರ್ ಪವರ್ ಅಂದ್ರೆ ಪವರ್ ಡೆವಲಪ್ಡ್ ಬೈ ದ ಮೋಟರ್, ಲೋಡ್ ಪವರ್ ಅಂದ್ರೆ ಪವರ್ ರಿಕ್ವೈರ್ಡ್ ಟು ಮೂವ್ ದ ವೆಹಿಕಲ್. ಸೊ ಈ ಬ್ಲೂ ಲೈನ್ ಇದೆಯಲ್ಲ, ಇದು ಈ ಕಾನ್ಸ್ಟೆಂಟ್ ಬಂದು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆಯಲ್ಲ, ದಟ್ ಈಸ್ ಮೋಟರ್ ಔಟ್ಪುಟ್ ಆಫ್ ದ ಮೋಟರ್. ಈ ರೆಡ್ ಕಲರ್ ಲೈನ್ ಇದೆ ಸ್ಲೋಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತಲ್ಲ, ಅದು ಪವರ್ ರಿಕ್ವೈರ್ಡ್. ಅಂದ್ರೆ ರೋಡ್ ಮೇಲೆ ವೆಹಿಕಲ್ ಮೂವ್ ಆಗಲಿಕ್ಕೆ ಎಷ್ಟು ಪವರ್ ಬೇಕಲ್ಲ, ದಟ್ ಇಸ್ ಅಂತ ಬರ್ತದೆ ರೋಡ್ ಲೋಡ್ ಪವರ್ ಆರ್ ಪವರ್ ರಿಕ್ವೈರ್ಡ್. This dotted line is nothing but the maximum speed. X-axis is the vehicle speed. First graph red road power discuss ಮಾಡೋಣ. Power required. Speed ಜಾಸ್ತಿ ಆದಾಗೆ power ಜಾಸ್ತಿ ಬೇಕಾ? ಅಗ್ರೀನಾ? ನಾವು ಜಾಸ್ತಿ ತಗೊಳ್ಳಿ, ನಾವು ಜಾಸ್ತಿ ಸ್ಪೀಡ್ ಹೋಗ್ತದೆ ಅಂದ್ರೆ ನಮ್ಮಲ್ಲಿ ಪವರ್ ಜಾಸ್ತಿ ಇರಬೇಕು ತಾನೆ. ನಾವು ನಿಧಾನಕ್ಕೆ ಹೋಗ್ತೀವಿ ಅಂದ್ರೆ ನಮ್ಮ ಪವರ್ ಕಡಿಮೆ ಇದ್ರೆ ಸಾಕು. ಬಟ್ ನಾವು ಜಾಸ್ತಿ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಹೋಗ್ತೀವಿ ಅಂದ್ರೆ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಬೇಕು, ಪವರ್ ಜಾಸ್ತಿ ಬೇಕು. ನಾವು ಸ್ಲೋ ನಿಧಾನ ನಡ್ಕೊಂಡು ಹೋಗ್ತಿದ್ದೀವಿ ಅಂದ್ರೆ ಎನರ್ಜಿ ಕಡಿಮೆ ಬೇಕು, ಪವರ್ ಕಡಿಮೆ ಬೇಕು. ಅಗ್ರೀನಾ?
Yes sir.
ಹೌದಾ? ಸೇಮ್ ಥಿಂಗ್ ಹ್ಯಾಪನ್ ಫಾರ್ ದ ವೆಹಿಕಲ್ ಆಲ್ಸೋ. If the vehicle speed is increasing, the load power is also, motor power required is also increasing. Nodi, as the vehicle speed increased from 0 to 50, 100, 150, 200 and 250 km per hour, the correspondingly power required is increasing gradually. ಇದೇ ರೀತಿಯ ಸ್ಪೀಡ್ ಇಲ್ಲಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋದ್ರೆ ಈ ರೆಡ್ ಕಲರ್ ಕೂಡ ಏನಾಗುತ್ತೆ, ಗೋಸ್ ಆನ್ ಇನ್ಕ್ರೀಸಿಂಗ್. So this is the relation between the power required versus vehicle speed. Now come to the motor power. Motor power initially it is a constant. See, because at load speeds motor delivers a constant power. Low speeds kadime iddage 150 iddage, so motor delivers a constant power. It is a constant power. If the motor speed increases behind this point, then the motor speed or motor power goes on decreasing. This is the point where we will get the maximum speed, where motor power equal to the required power. Available power equal to the power required. This is the point where you will get the maximum speed of a vehicle. ಯಾವ ಕಂಡೀಷನ್ ಅಂದ್ರೆ ಮೋಟರ್ ಪವರ್ ಮತ್ತೆ ರೋಡ್ ಪವರ್ ಈಕ್ವಲ್ ಆಗಿರಬೇಕು. ಸೊ ಒಂದು ನೆನಪಿರಲಿ, ಎರಡು ಪಾಯಿಂಟ್ಸ್ ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಫಸ್ಟ್ ಪಾಯಿಂಟ್, ಪವರ್ ರಿಕ್ವೈರ್ಡ್ increases with increasing the vehicle speed. Motor power is constant at the initial speed and later it reaches to the goes on decreasing when it exceeds the maximum speed. Maximum speed increase ಮಾಡ್ತಂತ ಹೋದಂಗೆ so motor power ಕೂಡ decrease ಆಗ್ತಂತ ಹೋಗುತ್ತೆ. So this is the point where the maximum speed occurs. The condition is when motor power is when maximum speed is high, motor power should be equal to the road power. So this is the typical behavior of an electric vehicle. Constant power region is 0 to base speed, for example 0 to 150 km per hour. Behind maximum speed, vehicle cannot accelerate further. Maximum speed ಆದಮೇಲೆ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ acceleration ಕೊಡಕ್ಕೆ ಅದೇ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಒಂದ್ಸಲಿ ಒಬ್ಬನ್ ಜಾಸ್ತಿ maximum ಒಂದು vehicle 180 km per hour maximum speed ಇದೆ ಅಂದ್ರೆ ನೀವು ಎಷ್ಟೇ accelerator ಇನ್ನೂ ಜಾಸ್ತಿ ಪ್ರೆಸ್ ಮಾಡಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ನೀವು ಪ್ರೆಸ್ ಮಾಡಿದ್ರು ಕೂಡ the vehicle it will not go behind the maximum speed. This is the characteristics of power versus vehicle speed. Third one is the acceleration characteristics of an electric vehicle. Look into this. Look into the graph. You need to remember these graphs because very important for the examination point of view also. And when you design the electric vehicle, these characteristics we need to remember. what I given the statement in the previous slide, that exactly matches with the current slide. The one statement I given with respect to acceleration, the same statement can be validated here with using this characteristic, that is speed versus time. Speed versus time gives the acceleration characteristics of an electric vehicle. ನಿಮ್ಮ ಅನಿಸಿಕೆ ಏನು? ಪೆಟ್ರೋಲ್ ಗಾಡಿಗಳು ಆಕ್ಸಲರೇಷನ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ? ಯಾವುದು ಆಕ್ಸಲರೇಷನ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಪೆಟ್ರೋಲ್ ವೆಹಿಕಲ್ ಅಥವಾ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್?
I think EV
EV car has the more acceleration. What it mean acceleration is in the extra class I said ನೆನಪಿರಲಿ ಈ ಡಿಫರೆನ್ಸ್ ಯಾವತ್ತೂ ನೆನಪು ಮರಿಬಾರ್ದು. ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡಬೇಕಾದ್ರೆ ಫೋರ್ಸ್ ಇಂದು ಟಾರ್ಕ್ ಇಂದು ಡಿಫರೆನ್ಸ್ ಕರೆಕ್ಟ್ ಗೊತ್ತಿರಬೇಕು. ವೆಹಿಕಲ್ ಸ್ಪೀಡ್, ವೆಹಿಕಲ್ ಆಕ್ಸಲರೇಷನ್ ಇವೆರಡು ಡಿಫರೆನ್ಸ್ ಕರೆಕ್ಟ್ ಗೊತ್ತಿರಬೇಕು. ನೆನಪಿರಲಿ. Force in unit ನೆನಪಿಟ್ಟುಕೊಂಡ್ರೆ you can easily remember. Force in unit to Newton, torque in unit to Newton meter, speed in unit to meter per second ಅಥವಾ ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಅಂತ ಹೇಳ್ಬೋದು. ಲಾರ್ಜರ್ ಯೂನಿಟ್ ಅಲ್ಲ, ಅದನ್ನ ನೆನಪಿಟ್ಟುಕೊಳ್ಳೋಕೆ ಈಸಿ ಆದರೆ. ಆಕ್ಸಲರೇಷನ್ ಅಂದ್ರೆ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್, ದಟ್ ಈಸ್ ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್. ಇನ್ನೊಂದ್ಸರಿ ಹೇಳ್ತೀನಿ, ಆಕ್ಸಲರೇಷನ್ ಅಂದ್ರೆ ಹೌ ಕ್ವಿಕ್ಲಿ ವೆಹಿಕಲ್ increases, how fastly vehicle increases its speed per second. One per second ಅಲ್ಲಿ ಎಷ್ಟು ಫಾಸ್ಟ್ ಆಗಿ ಅದು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಇದ್ರ ಸ್ಪೀಡ್ ಅನ್ನೋದನ್ನೇ ಆಕ್ಸಲರೇಷನ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಎಷ್ಟು ಸ್ಪೀಡ್ ಅಲ್ಲಿ ವೆಹಿಕಲ್ ಹೋಗ್ತಾ ಇದೆ ಅನ್ನೋದು ವೆಲಾಸಿಟಿ ಅಂತ ಕರೀತೀವಿ. ಗೊತ್ತಾಗ? ಸೊ this acceleration characteristics explains the speed versus the time. ನೋಡಿ, as the time increases, speed as goes on increases. This speed, that is in terms of kilometer per hour. See, acceleration characteristics show how quickly an electric vehicle can increase its speed from the rest. So at this point, the acceleration becomes constant, because in the last slide, as I said, remember, the point alli, behind the maximum speed, vehicle cannot accelerate further. Once the maximum speed reach ಆದ್ಮೇಲೆ ವೆಹಿಕಲ್ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಆಕ್ಸಲರೇಟ್ ಮಾಡೋಕ್ಕಾಗೋದಿಲ್ಲ. ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಇಟ್ ಹ್ಯಾಸ್ ಸಮ್ ಪಾಯಿಂಟ್ ವೇರ್ ವಿ ಕ್ಯಾನಾಟ್, ಬಿಹೈಂಡ್ ದಟ್ ಒನ್ ವಿ ಕ್ಯಾನಾಟ್ ಆಕ್ಸಲರೇಟ್. ಸಿ ಹಿಯರ್ at this point, this is the typical, this is the point where after this one speed goes on constant. So from 0 to 60 km per hour, some vehicle takes the 60 to 10 kilometers. That is, passenger electric vehicle takes 60 to 10 kilometers, 10 seconds. ನೀವು ನಿಮ್ಮ ಗಾಡಿ ಹೊಡಿಬೇಕಾದ್ರೆ ನೋಡಿ, ಪೆಟ್ರೋಲ್ ಗಾಡಿ ಅಥವಾ ಪೆಟ್ರೋಲ್ ಕಾರ್ ಹೊಡಿಬೇಕಾದ್ರೆ ನೋಡಿ, 0 to 60 ಕಿಲೋಮೀಟರ್ ರೇಂಜ್ ರೀಚ್ ಆಗಿ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅಂತ ಚೆಕ್ ಮಾಡಿ. ಯಾರ್ದಾರ ಎರಡು ಗಾಡಿ ಇದ್ರೆ ಎರಡು ಚೆಕ್ ಮಾಡಿ. ನಿಮ್ದು ಇವಿ ಕಾರ್ ಇದ್ರೆ ಇವಿ ಕಾರ್ ಚೆಕ್ ಮಾಡ್ರಿ, ನಿಮ್ದು ಪೆಟ್ರೋಲ್ ಕಾರ್ ಇದ್ರೆ ಪೆಟ್ರೋಲ್ ಕಾರ್ ಚೆಕ್ ಮಾಡ್ರಿ. ಎರಡನ್ನ ಕಂಪೇರ್ ಮಾಡಿ. 0 to 100 ಕಿಲೋಮೀಟರ್ ರೀಚ್ ಆಗಲಿಕ್ಕೆ ಯಾವುದು ಜಾಸ್ತಿ ಟೈಮ್ ತಗೊಳುತ್ತೆ ಅಂತ ಚೆಕ್ ಮಾಡಿ. EV will be preferably good in rising its value from 0 to 100 km within 10 seconds. So these are the factors that affect the acceleration, motor torque and power, ವೆಹಿಕಲ್ ಮಾಸ್ ಆಬ್ವಿಯಸ್ಲಿ ಎಷ್ಟು ಜಾಸ್ತಿ ಇರುತ್ತೋ, ವೆಹಿಕಲ್ ಎಷ್ಟು ಜಾಸ್ತಿ ಇರುತ್ತೋ ಅಷ್ಟು ಆಕ್ಸಲರೇಷನ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಬ್ಯಾಟರಿ ಪವರ್ ಕೆಪಾಬಿಲಿಟಿ ಆಬ್ವಿಯಸ್ಲಿ ಬ್ಯಾಟರಿ ಪವರ್ ಜಾಸ್ತಿನೇ ಬೇಕು, ಆಕ್ಸಲರೇಷನ್ ಜಾಸ್ತಿ ಬೇಕು. ಅಂದರೆ ಟೈರ್ ರೋಡ್ ಟ್ರಾಕ್ಷನ್, ದಟ್ ಇಸ್ ದ ರೋಲಿಂಗ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ವಾಟ್ ವಿ ಸೇ. ಏರೋಡೈನಮಿಕ್ ಡ್ರ್ಯಾಗ್ ಅಂದರೆ ಅಪೋಸಿಷನ್ ಅಲ್ಲಿ ಸ್ಪೀಡ್ ಎಷ್ಟು ಫಾಸ್ಟ್ ಆಗಿ ಬರ್ತಾ ಇದೆ ಅನ್ನೋದು ನಿಮಗೆ ಮ್ಯಾಟರ್ ಆಗುತ್ತೆ. ಬಿಕಾಸ್ ಆಲ್ವೇಸ್ ಸ್ಪೀಡ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ ದ completely tractive force, as I said, TF, T fraction. The same thing here, tire road traction, aerodynamics and road gradient. These three parameters are with respect to the traction force. These two are with respect to the motor torque, vehicle mass and battery power. So mass into acceleration is equal to tractive force minus road resistance force, that is F resistance. Total resistance force, m is the vehicle mass, a is the acceleration. If simple example is given to understand the acceleration, if the vehicle is taken 7.5 seconds to reach its speed from 0 to 100 kilometers, then the observed acceleration should be 3.7 meter per second square. ಅಂದರೆ ಯಾವುದೇ ಒಂದು ವೆಹಿಕಲ್ 0 to 100 ಕಿಲೋಮೀಟರ್ ರೀಚ್ ಆಗಲಿಕ್ಕೆ 7.5 ಸೆಕೆಂಡ್ಸ್ ತಗೊಂತಿದೆ ಅಂದರೆ ಅದರ ಅವರೇಜ್ ಆಕ್ಸಲರೇಷನ್ ಎಷ್ಟು ಇರುತ್ತೆ ಅಂದರೆ 3.7 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್. 1 ಸೆಕೆಂಡಿಗೆ 3.7 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಷ್ಟು ಜಾಸ್ತಿ ಆಗಿ ಹೋಗಬೇಕು. ಅದರ ಸ್ಪೀಡ್ ಏನು? 1 ಸೆಕೆಂಡಿಗೆ 3.7 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಷ್ಟು ಜಾಸ್ತಿ ಆಗಿ ಹೋಗ್ತಿದ್ರು ಮಾತ್ರ vehicle reaches to 0 to 100 km per hour with time of 7.5 seconds. This is the relation between speed and time, or with respect to the acceleration and time. Next, gradability. ನೀವು ಹೇಳಿ, ಈ ತಿಳ್ಕೊಂಡಿರೋ ಪ್ರಕಾರ ಗ್ರೇಡಬಿಲಿಟಿ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಯಾವ ರೀತಿ ಇರುತ್ತೆ? ಥೀಟಾ ಜಾಸ್ತಿ ಆದಾಗೆ ಅಥವಾ ಥೀಟಾ ಜಾಸ್ತಿ ಆಗಿದೆ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೋ, ಅಥವಾ ಥೀಟಾ ಕಡಿಮೆ ಆದಾಗ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಆಗುತ್ತೋ? ಥೀಟಾ ಕಡಿಮೆ ಇದ್ರೆ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ, ಅಥವಾ ಥೀಟಾ ಜಾಸ್ತಿ ಇದ್ರೆ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ? ನೀವು ತಿಳ್ಕೊಂಡಿರೋ ಪ್ರಕಾರ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಗ್ರೇಡಿಯಂಟ್, ದಟ್ ಇಸ್ ಸೈನ್ ಥೀಟಾ. ಯಾರಾದರೂ? ಯಾರಾದ್ರೂ ಗ್ರೇಡಿಯಂಟ್ ಥೀಟಾ ಸ್ಲೋಪ್ ಜಾಸ್ತಿ ಇದ್ದಾಗ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ, ಸ್ಲೋಪ್ ಕಡಿಮೆ ಇದ್ದಾಗ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ?
ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಇದ್ದಾಗ ಥೀಟಾ ಕಡಿಮೆ ಇರುತ್ತೆ.
ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಥೀಟಾ ಹೇಳಬೇಕು, ಸ್ಪೀಡ್ ಹೇಳಬಾರ್ದು. ವೇರಿಯಿಂಗ್ ಪ್ಯಾರಾಮೀಟರ್ ಥೀಟಾ. ಈಗ ಥೀಟಾ ಜಾಸ್ತಿ ಇದ್ರೆ ಸ್ಪೀಡ್ ಏನಾಗುತ್ತೆ?
ಲೋ ಇರುತ್ತೆ ಸರ್, ಲೋ.
ವೆರಿ ಗುಡ್, ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೇಮ್ ಎಲ್ಲಮ್ಮ ಈ ಹಿಲ್ ಏರಿಯಾದಲ್ಲಿ ತೋರಿಸಿದ್ರು ನೋಡಿ, ವೆಹಿಕಲ್ ಈ ರೀತಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಈ ಸ್ಲೋಪ್ ಇದೆ, ಇದು ಫ್ಲಾಟ್ ಏರಿಯಾ, ದಿಸ್ ಇಸ್ ದ ಥೀಟಾ. ಇದು ಹಿಲ್ ಏರಿಯಾ, ಅಪ್ ಏರಿಯಾ ಅನ್ಕೋಣ. ಈ ಅಪ್ ಏರಿಯಾದಲ್ಲಿ ನಿಮ್ಮ ವೆಹಿಕಲ್ ಟೂ ವೀಲರ್ ಓಡಿಸ್ತಾ ಇದ್ರೆ, ಅಪ್ ಏರಿಯಾದಲ್ಲಿ ನೀವು ಬೈಕ್ ಓಡಿಸ್ತಾ ಇದ್ರೆ ಬಿಗ್ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೋ ಕಡಿಮೆ ಇರುತ್ತೋ? ಕಡಿಮೆ ಇರುತ್ತೆ ಆಬ್ವಿಯಸ್ಲಿ. ನೀವು ಫ್ಲಾಟ್ ಫ್ಲಾಟ್ ಏರಿಯಾದಲ್ಲಿ ನಿಮ್ಮ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಯಾಕಂದ್ರೆ ಗ್ರೇಡಿಯಂಟ್ ಏರಿಯಾದಲ್ಲಿ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಇರುತ್ತೆ. as theta goes on increasing from surface here, this is the angle with respect to the surface level and the vehicle where we are moving. So ಈ angle slope angle ಜಾಸ್ತಿ ಯಾಕೆ ಅಂತ ಹೋದ್ರೆ ಇದು ಸ್ಪೀಡ್ ಏನಾಗುತ್ತೆ ಕಡಿಮೆ ಯಾಕೆ ಅಂತ. ಈ ಥೀಟಾ ಕಡಿಮೆ ಯಾಕೆ ಅಂತ ಬಂದ್ರೆ the speed ಜಾಸ್ತಿ ಆಗುತ್ತೆ. See, it is the gradability of an electric vehicle or on the hill climbing capability. Gradient ಜಾಸ್ತಿ ಇದ್ರೆ ಸ್ಪೀಡ್ ಏನಿರುತ್ತೆ ನೋಡಿ, ಗ್ರೇಡಿಯಂಟ್ ಇಲ್ಲಿ ಎಷ್ಟಿದೆ? ಈ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ತಗೊಳ್ಳಿ, ಗ್ರೇಡಿಯಂಟ್ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ? 50% ಇದೆ, 44% ಇದೆ. ಕಾಣಿಸ್ತಾ ಇದೆನಾ? ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ, ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ gradient ಎಷ್ಟಿದೆ corresponding horizontal line y-axis ಗೆ almost 45%. 45% ಇದ್ದಾಗ ಅದೇ ಲೈನ್ x-axis ತಗೊಂಬನ್ನಿ. ಈ x-axis ಅಲ್ಲಿ represents the vehicle speed. ಸ್ಪೀಡ್ ಎಷ್ಟಿದೆ? ಇದು 20 ಅಂದರೆ it is almost less than 10, almost 5 ಕಿಲೋಮೀಟರ್ ಇದೆ. ಸೊ ಗ್ರೇಡಿಯಂಟ್ ಜಾಸ್ತಿ ಇದ್ದಾಗೆ ಸ್ಪೀಡು 5 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಇದೆ. ನೋಡಿ 45% ಗ್ರೇಡಿಯಂಟ್ ಇದ್ದರೆ ಸ್ಪೀಡು 5 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಇದೆ. ಅದೇ ನಿಮಗೆ ಗ್ರೇಡಿಯಂಟ್ ಡಿಕ್ರೀಸ್ ಆಕ್ಕಿಂತ ಬರ್ತಾ ಇದೆ. ಇಲ್ಲಿ ಗ್ರೇಡಿಯಂಟ್ ಡಿಕ್ರೀಸ್ ಆಕ್ಕಿಂತ ಈ ಪಾಯಿಂಟ್ ಬಂದಾಗ ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ ಗ್ರೇಡಿಯಂಟ್ ಆಲ್ಮೋಸ್ಟ್ 20% ಇದೆ. ಸ್ಪೀಡ್ ಎಷ್ಟಿದೆ 40 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಇದೆ. ಅದೇ ಗ್ರೇಡಿಯಂಟ್ ಇನ್ನೂ ಡಿಕ್ರೀಸ್ ಆಕ್ಕಂತ ಬಂದರೆ ದೆನ್ ಗ್ರೇಡಿಯಂಟ್ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ 5% ಇದೆ. 5% ಸ್ಪೀಡ್ ಏನಿದೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಇದೆ ಎಷ್ಟಿದೆ 100 ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್. ವಾಟ್ ಇಟ್ ಶೋಸ್ as the gradient goes on decreases speed goes on increases. X-axis represents the vehicle speed, y-axis represents the percentage of gradability. Gradability is always in terms of percentage. 0% flat road 0% ಅಂತ ಹೇಳ್ತೀವಿ. ಅದೇ ಫ್ಲಾಟ್ ರೋಡ್ ಸ್ಲೋಪ್ ಯಾಕೆಂತ ಹಪ್ಪಿಲ್ಲ ಯಾಕೆಂತ ಹೋದ್ರೆ ಅದು ಪರ್ಸೆಂಟೇಜ್ ಜಾಸ್ತಿ ಅಂತ ಹೇಳ್ತೀವಿ. So what we can say from these characteristics, as the gradient goes on decreasing, vehicle speed goes on increasing. Gradient ಜಾಸ್ತಿ ಇದ್ರೆ vehicle speed ಕಡಿಮೆ ಇರುತ್ತೆ. ಅಂದ್ರೆ ಹಪ್ಪು ಜಾಸ್ತಿ ಇದ್ರೆ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಇರುತ್ತೆ. ಹಪ್ಪು ಕಡಿಮೆ ಇದ್ರೆ ಸೊ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. This is a relation between gradability, percentage of gradability and vehicle speed. It is shown in this figure. ಕಾರಲ್ಲಿ ತೋರಿಸಿದ್ದಾರೆ. So gradability formula in terms of percentage, tractive force minus rolling resistance plus aerodynamic drag divided by the vehicle weight into 100%. A simple example is given here with some values. If the tractive force is 4000 Newton, rolling resistance is 600 Newton, gradient is 400, vehicle mass is 12,000 Newton. So the gradability is using this formula, Ft is 4000 minus Fr is 600 plus Fd is 400 divided by 12,000 into 100, weight of the mass, vehicle weight, that is W. So altogether we calculate this one, gradability becomes 25%. If this 25% increases to 40%, then the speed reduces. If this 25% decreases, then the speed increases. So gradability, what we can conclude, gradability is highest at low speeds and reduced as speed increases. It also depends on tractive force. See here, the formula itself says it is a tractive force and resistance, road resistance, vehicle weight and driving conditions. It is all depend upon these four parameters with respect to this formula. Ft, tractive force, road resistance and gradient. And driving conditions. Next one, energy consumption characteristics of an electric vehicle. See the graph. You have to see, just analyze what is y-axis, what is x-axis, how the curve is. If you see how the curve is, you can define like relation between those two parameters, x-axis parameters and y-axis parameters. ಏನು ಗೊತ್ತಾಯ್ತು ಇದರಿಂದ, ಈ ಗ್ರಾಫಿಂದ? This characteristic represents energy consumption in terms of watt hour per kilometer versus vehicle speed in terms of kilometer per hour. So, vehicle speed from 0 to 150 increased ಇಲ್ಲಿ energy consumption from 0 to 300 watt hour per kilometer. There are three different regions shown here. This is the first region, this is the middle region, this is high speed region. The first region is called as low speed because the speed is within the 20 km per hour. This is the optimum region where it is the range from 20 to 80 km per hour. This is the high speed region where the speed of the vehicle increases beyond 80 km per hour. See, lower speed allidaage energy consumption ಜಾಸ್ತಿ ಇರುತ್ತೆ. For example, ನೀವು ಎಲ್ಲದೂ ನಿಮ್ಮ ವೆಹಿಕಲ್ ನೀವು ಹೊಡಿತಿರಲ್ಲ, ವೆಹಿಕಲ್ ಅದಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡ್ಕೋಬಹುದು. ನಿಮ್ಮ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ ಟಾರ್ಕ್ ಜಾಸ್ತಿ ಬೇಕು ತಾನೆ. ನೀವು ಗಾಡಿ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀರಾ, ಗಾಡಿ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಮುಂದಕ್ಕೆ ಹೋಗಬೇಕಾದ್ರೆ ಆ ಟೈಮ್ ಅಲ್ಲಿ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಅವಾಗ ಟಾರ್ಕ್ ಜಾಸ್ತಿ ಬೇಕಾ? ಹೌದಾ? ಯಾವುದೇ ವೆಹಿಕಲ್ ನೀವು ಸ್ಟಾರ್ಟ್ ಮಾಡೋದಕ್ಕೆ ಸ್ವಲ್ಪ ಸ್ಪೀಡ್ ಹೋಗೋದ್ರಿಗೆ, ಯಾಕಂದ್ರೆ ನೀವು ಗೇರ್ 1 or 2 ಗೇರ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಗೇರ್ ಅಥವಾ ಸೆಕೆಂಡ್ ಗೇರ್ ಅಲ್ಲೇ ಮೂವ್ ಮಾಡ್ತಿರ್ತೀರ. ಸ್ಟಾರ್ಟಿಂಗ್ ರೇಂಜ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಆರ್ ಸೆಕೆಂಡ್ ಗೇರ್ ಅಲ್ಲೇ ಮೂವ್ ಮಾಡ್ತಿರ್ತೀರ. ಹಾಗಾಗಿ ಅದರದ್ದು ಸ್ಪೀಡ್ ಕಡಿಮೆ ಇರುತ್ತೆ. ಆ ಸ್ಪೀಡ್ ಕಡಿಮೆ ಇದ್ದಾಗೆ ಟಾರ್ಕ್ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ. ಟಾರ್ಕ್ ಜಾಸ್ತಿ ಬೇಕಂದ್ರೆ ಎನರ್ಜಿ ಕನ್ಸಂಪ್ಷನ್ ಜಾಸ್ತಿ, ಎನರ್ಜಿ ಕನ್ಸಂಪ್ಷನ್ ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So same way the graph shows when their vehicle speed is, electric vehicle speed is less, then the energy consumption is more. See, as the speed goes on increasing, energy consumption decreases. Why it won't go to zero? ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆದಾಗ ಎನರ್ಜಿ ಕನ್ಸಂಪ್ಷನ್ ಜೀರೋ ಆಗಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಎನರ್ಜಿ ಕನ್ಸಂಪ್ಷನ್ ಜೀರೋ ಆಗ್ತಾ ಇದ್ರೆ ಬ್ಯಾಟರಿ ಡೆಡ್ ಆಯಿತು ಅಂತ ಅರ್ಥ, ಗಾಡಿ ಮುಂದಕ್ಕೆ ಹೋಗಲ್ಲ ಆಮೇಲೆ. ಸೊ as the speed goes on increases, the energy consumption decreases. This range is nothing but the nominal speed or optimum region of where driver can run this vehicle. We will use the higher efficiency and moderate losses. And the vehicle speed increases beyond this region, optimum region, the energy consumption again goes on increasing. ನೀವು ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಕ್ಕಂತ ಹೋದ್ರೆ ಎನರ್ಜಿ ಕನ್ಸಂಪ್ಷನ್ ಕೂಡ ಜಾಸ್ತಿ ಆಕ್ಕಂತ ಹೋಗುತ್ತೆ. So this is what, because the wave it is proportional to the v square. ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆದಂಗೆ ಅದರ ಡಬಲ್ ಅಷ್ಟು ಫೋರ್ಸ್ ಬೇಕಾಗುತ್ತೆ. ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಆದಂಗೆ ಎನರ್ಜಿ ಕನ್ಸಂಪ್ಷನ್ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ನಮಗೆ ಫಾರ್ಮುಲಾ ಇತ್ತಲ್ಲ, that proportional to the v square ಅಂತಂದು. So what we can conclude here, at lower region, at lower speed region, energy consumption is more because at starting we need to require more energy to start the vehicle from 0 to the higher value. Once the speed increases in the nominal range, that is in the optimum range, energy consumption is almost constant. It is the lowest among the two regions. As the speed increases, the energy consumption goes on increases because of it is proportional to the v square. It is a formula, energy consumption is equal to energy used divided by distance traveled, or energy consumption is equal to, in terms of kilowatt hour ಹೇಳೋದಾದ್ರೆ energy used in kilowatt hour divided by distance traveled. A simple example is given here. If an electric vehicle uses 18 kilowatt hour of energy to travel 120 km, then energy consumption is equal to 18 kilowatt hour is energy usage, energy used, that is 18 kilowatt hour. Distance traveled is 120 km, then the energy consumption is 150 watt hour per kilometer. Next one is the regenerative braking performance. During the regenerative braking, see, this is the motoring region where it is power is going to be increased. When we apply at this point, when we apply the braking, it goes on decreasing. See, it goes on. Regenerative braking means during the forward condition, supply is given from the battery to the field. When we apply the brake, the same power, the same motor acts as a generator, as we discussed earlier. the same motor acts as a generator, then the power from the wheel fed back to the battery, that shown in the negative region. This red line shows the negative power. Because this negative power is nothing but power won't go to negative. The negative shows that it is a regenerative braking region. The power is in the reverse condition. It means power in the normal motoring condition, forward condition, power from battery to the wheel. The power goes from battery to the wheel. When we apply the braking, that called as regenerative brake happens. That is, power from the wheel goes back to the battery. Under that condition, motor acts as a generator. See, this shows that means the power. This is a regenerative braking condition where power from the wheel goes back to the charge. So goes back to the battery. Once battery brake releases, then that energy, whatever during the regenerative braking, that charges the battery, that shows in the green line. The regenerative braking apply ಮಾಡಿದಾಗ battery goes to charge, that shows in the green line. This is the characteristics of power versus time. Then the last characteristics, that is charging time characteristics of electric vehicle. Charging time in terms of hours is equal to battery capacity. ಅಂದರೆ ಬ್ಯಾಟರಿ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಆದಂಗೆ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಜಾಸ್ತಿ ಅಂತ ಇದರಲ್ಲಿ ಹೇಳ್ತೀವಿ. ಬಟ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಓನ್ಲಿ ಡೈರೆಕ್ಟ್ಲಿ ರಿಲೇಟೆಡ್, ಇಟ್ ಈಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಚಾರ್ಜಿಂಗ್ ಪವರ್ ಇಂಟು ಚಾರ್ಜರ್ ಎಫಿಷಿಯನ್ಸಿ. So we cannot tell directly charging time is directly proportional to the battery capacity. ಅಂದರೆ ಬ್ಯಾಟರಿ ಜಾಸ್ತಿ ಕೆಪಾಸಿಟಿ ಇದ್ದರೆ ಅದು ಚಾರ್ಜ್ ಆಗಲಿಕ್ಕೆ ಜಾಸ್ತಿ ಟೈಮ್ ತಗೊಳುತ್ತೆ, ಬ್ಯಾಟರಿ ಕೆಪಾಸಿಟಿ ಕಡಿಮೆ ಇದ್ದರೆ ಅದು ಚಾರ್ಜ್ ಆಗಲಿಕ್ಕೆ ಕಡಿಮೆ ತಗೊಳುತ್ತೆ ಅಂತ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳಂಗಿಲ್ಲ. ಬಿಕಾಸ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್, ಓನ್ಲಿ ಒನ್ ಪ್ಯಾರಾಮೀಟರ್, ಇಟ್ ಡಿಪೆಂಡ್ಸ್ ಅಪಾನ್ and charging time inversely proportional to the charging power. Charging power ಜಾಸ್ತಿ ಇದ್ದರೆ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಚಾರ್ಜರ್ ಎಫಿಷಿಯನ್ಸಿ ಜಾಸ್ತಿ ಇದ್ದರೆ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಕೂಡ ಕಡಿಮೆ ಆಗುತ್ತೆ. See these two we have drawn here, charging time versus charger power. Y axis represents the charging time, x axis represents the charging power. This graph represents charging time versus charger power. ಯಾವ ರೀತಿ ಡೈರೆಕ್ಟ್ ರಿಲೇಷನ್, ಡೈರೆಕ್ಟ್ ಪ್ರಪೋರ್ಷನಲ್ ಅಥವಾ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್?
Inversely, sir.
As these two are inversely proportional, that means if the charger power increases, charging time decreases. If the charger power decreases, charging time increases. Right? It is always dependent upon the charging power, charger power. See, when the charger power is less, see, both are inversely proportional. So charger power is x-axis from 0 to 350 kilowatt, where charging time is from 0 to 12 hours. So charger power ಕಡಿಮೆ ಇದ್ದರೆ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಎಷ್ಟಾಗ್ತದೆ? 10 hours ಇದೆ. ಇಲ್ಲಿ ನೋಡಿ, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಪವರ್ ಎಷ್ಟಿದೆ? ಇಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ 15 ಕಿಲೋವ್ಯಾಟ್ ಇರಬಹುದು. ಇದು 50 ಇದೆ ಅಂದ್ರೆ ಗ್ರಾಫ್ 25, ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಇದ್ರೆ 10 ಇದೆ, 10 to 15 ಇರಬಹುದು. ಚಾರ್ಜರ್ ಪವರ್ 15 ಇದ್ರೆ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಎಷ್ಟಿದೆ? 10 hours ಇದೆ. ಸೊ ಅದೇ ರೀತಿ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ ಯಾವಾಗ? ಎಕ್ಸ್ ಆಕ್ಸಿಸ್ ಜಾಸ್ತಿ ಆದಂಗೆ, ಅಂದ್ರೆ ಚಾರ್ಜಿಂಗ್ ಪವರ್ ಜಾಸ್ತಿ ಆದಂಗೆ. ನೋಡಿ, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಚಾರ್ಜಿಂಗ್ ಪವರ್, ಚಾರ್ಜರ್ ಪವರ್ 50 ಕಿಲೋವ್ಯಾಟ್ ಇದೆ, ಬಟ್ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಎಷ್ಟಿದೆ? 3.3 ಅವರ್ ಇದೆ. ಅದೇ ಪವರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀನಿ. ನೋಡಿ, ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ 1.1 ಅವರ್ ಇದೆ, 250 ಅಲ್ಲಿ 0.6 ಅವರ್ ಇದೆ, 300 ಕಿಲೋವ್ಯಾಟ್ ಅಲ್ಲಿ 0.5 ಅವರ್ ಇದೆ, 350 ಕಿಲೋವ್ಯಾಟ್ ಅಲ್ಲಿ 0.4 ಅವರ್ ಇದೆ. 0.4 ಅವರ್ ಅಂದ್ರೆ is almost less than 30 minutes. That means charging time is dependent upon the charging power. Both are inversely proportional. As the charging power increases, charging time decreases. Simple ಆಗಿ ಹೇಳ್ತೀನಿ, ಉಸೇನ್ ಬೋಲ್ಟ್ 200 ಮೀಟರ್ ಓಡಲಿಕ್ಕೆ ಜಾಸ್ತಿ ಟೈಮ್ ಕಡಿಮೆ ಟೈಮ್ ಜಾಸ್ತಿ ಎಷ್ಟು ಟೈಮ್ ಕಡಿಮೆ ಟೈಮ್ ತಗೊಂತಾನೋ, ಅಥವಾ ಇಲ್ಲಿ ನಿಮ್ಮಲ್ಲ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಯಾರು ಒಬ್ಬರೇ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಕ್ಸ್ ಅನ್ಕೊಳ್ಳೋಣ, ಇವತ್ತು ಯಾರು ಆಬ್ಜೆಕ್ಟ್ ಇದ್ದಾರೆ ಅವಾಗದೇ ತಗೊಳ್ಳೋಣ. ಯಾರು ಆಬ್ಜೆಕ್ಟ್ ಇದ್ದಾರೆ ಇವತ್ತು? ಯಾರು ಎಕ್ಸ್ ಪರ್ಸನ್, ನಾರ್ಮಲ್ ಪರ್ಸನ್ ಎಕ್ಸ್ ಪರ್ಸನ್ ಅನ್ಕೊಳ್ರಿ, ನನ್ನೇ ತಗೊಳ್ರಿ. ಉಸೇನ್ ಬೋಲ್ಟ್ 100 ಮೀಟರ್ ಕಡಿಮೆ ಟೈಮ್ ಓಡ್ತಾನೋ, ನಾನು 100 ಮೀಟರ್ ಕಡಿಮೆ ಟೈಮ್ ಓಡ್ತೀನೋ? ಉಸೇನ್ ಬೋಲ್ಟ್ ಕೇಳಿದ್ರೆ ತಾನೆ?
ಹಾ ಸರ್, ಕೇಳಿದ್ದೆ.
ಅವನ 100 ಮೀಟರ್ ಜಾಸ್ತಿ ಕಡಿಮೆ ಟೈಮಲ್ಲಿ ರೀಚ್ ಆಗ್ತಾನೋ, ನಾನು ಕಡಿಮೆ ಟೈಮಲ್ಲಿ ರೀಚ್ ಆಗ್ತೀನೋ?
Usain Bolt, sir.
ಉಸೇನ್ ಬೋಲ್ಟ್. ಯಾಕೆ?
Practice and this field is very excellent.
ಪವರ್, ಇನಿಷಿಯಲಿ ಪವರ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಹೌದಾ? ಪವರ್ ಜಾಸ್ತಿ ಇದ್ರೆ ಸ್ಪೀಡ್ ಆಗಿ ಓಡೋಕೆ ಸಾಧ್ಯ. ಪವರ್ ಇಲ್ಲ ಅಂದ್ರೆ ಸ್ಪೀಡ್ ಆಗಿ ಓಡೋಕೆ ಸಾಧ್ಯ. ಪ್ರಾಕ್ಟೀಸ್ ಇಸ್ ಓಕೆ, ಬಟ್ ಪ್ರಾಕ್ಟೀಸ್ ಮೇಕ್ಸ್ ಮೋರ್ ಪವರ್. ಪವರ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಅವರಿಗೆ. ಸೊ ನಮ್ಮಂತ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ಸ್ ಪವರ್ ಕಡಿಮೆ ಇರುತ್ತೆ. ಸೊ ಅದೇ ರೀತಿನೇ ಪವರ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದ್ರೆ ಉಸೇನ್ ಬೋಲ್ಟ್ ಪವರ್ ಜಾಸ್ತಿ ಇದೆ, ಟೈಮ್ ಕಡಿಮೆ, ಟೈಮ್ ಯೂಸ್ ಮಾಡೋದು ಕಡಿಮೆ. ನಮ್ಮಲ್ಲಿ ಪವರ್ ಕಡಿಮೆ ಇದೆ, ಸೊ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಸ್ಪೀಡ್ ಹೇಳೋದಾದ್ರೆ ಸೊ ಟೈಮ್ ಜಾಸ್ತಿ ತಗೊಂತೀವಿ. ಅದೇ ರೀತಿನೇ ಚಾರ್ಜರ್ ಪವರ್ ಜಾಸ್ತಿ ಆದಂಗೆ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಕೂಡ ಕಡಿಮೆ ಯಾಕೆಂತ ಹೋಗುತ್ತೆ. ಸೊ ಬೋತ್ ಆರ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. It is a battery performance. So this is again it is shown is the charging time. Charger power ಜಾಸ್ತಿ ಇದ್ರೆ charging time decrease ಅಂತ ಹೇಳಿದ್ವಿ. ಇಲ್ಲೂ ಕೂಡ with respect to charger power with respect to state of charge ಹೇಳಿದ್ವಿ. ಇಲ್ಲಿ state this is also with respect to SOC, that is state of charge. As the usable energy increases, state of charge decreases. ಅಂದ್ರೆ ನಾವು ಎಷ್ಟು ಯೂಸ್ ಮಾಡ್ಕೊಂತ ಹೋದಂಗೆ ಅದರ ಚಾರ್ಜಿಂಗ್ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ನಾವು ಮೊಬೈಲ್ ಒಂದ್ಸಲ ಫುಲ್ ಚಾರ್ಜ್ ಮಾಡಿದ್ರೆ ನಾವು ಎಷ್ಟು ಅಪ್ಲಿಕೇಶನ್ಸ್ ಯೂಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ತೀವೋ, ಎಷ್ಟರಲ್ಲಿ ನಾವು ಮೊಬೈಲ್ ಆನ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂತೀವೋ, ಅಂದ್ರೆ ರಿಯಲ್ ಲೈವ್ ಅಲ್ಲಿ ಇಟ್ಕೊಂತೀವೋ, ಅದರ ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಚಾರ್ಜ್ ಕಡಿಮೆ ಆಗುತ್ತೆ ಹೋಗುತ್ತೆ. ದ ಸೇಮ್ ಥಿಂಗ್ ಎಕ್ಸ್ಪ್ಲೇನ್ಸ್ ಹಿಯರ್. This is all characteristics come into the single slide. So why vehicle performance analysis? Now seeing all these things, ಯಾಕೆ ನಾವು ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಅನಾಲಿಸಿಸ್ ಮಾಡಬೇಕು? ಯಾಕೆ ನಾವು ಚಾರ್ಜಿಂಗ್ ಟೈಮ್, ಬ್ಯಾಟರಿ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಬಗ್ಗೆ ತಿಳ್ಕೊಂಡಿರಬೇಕು, ಚಾರ್ಜಿಂಗ್ ಟೈಮ್ ಗೊತ್ತಿರಬೇಕು, ಈ ರೀಜನರೇಟಿವ್ ಬ್ರೇಕಿಂಗ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಗೊತ್ತಿರಬೇಕು, ಎನರ್ಜಿ ಕನ್ಸಂಪ್ಷನ್ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಗೊತ್ತಿರಬೇಕು, ಗ್ರೇಡಬಿಲಿಟಿ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಗೊತ್ತಿರಬೇಕು, ಆಕ್ಸಲರೇಷನ್, ಸ್ಪೀಡ್, ಡ್ರೈವಿಂಗ್ ರೇಂಜ್. ಯಾಕೆ ತಿಳ್ಕೋಬೇಕು? To design any vehicle, we need to know these characteristics. Unless we know these characteristics, we cannot design in an electric vehicle. So, electric vehicle design ಮಾಡೋದಂದ್ರೆ that is nothing but selection of motor power, battery capacity determination, evaluation of acceleration performance, maximum speed assessment, gradability analysis, driving range prediction, energy efficiency improvement, regenerative braking, optimization, thermal management design, vehicle safety and reliability, cost optimization, complicit standards. ಇದೆಲ್ಲನೂ ನೋಡ್ಕೊಳ್ಳಿಕ್ಕೋಸ್ಕರ we need to know the performance analysis of an electric vehicle is very important in designing and selection of these parameters. So finally, some factors will affect the performance of an electric vehicle, that are battery capacity and state of charge, motor power and its efficiency, mass of the vehicle, aerodynamic resistance, rolling resistance, road gradient, driving style, obviously, ambient temperature. So last concept, so safety consideration. Obviously, if you take any vehicle in the first class, I said, now starting electric vehicle design ಮಾಡಿ ರೋಡ್ ಬಿಟ್ಟಾಗೆ ಬಹಳ ನೆಗೆಟಿವ್, ಅದ್ರ ಬಗ್ಗೆ ನೆಗೆಟಿವ್ ತಿಳ್ಕೊಂಡಿದ್ವಿ. ಅಂದ್ರೆ ಚಾರ್ಜಿಂಗ್ ಸ್ಟೇಷನ್ ಅಲ್ಲಿ ಬ್ಲಾಸ್ಟ್ ಆಯ್ತು, ಅಲ್ಲಿ ಚಾರ್ಜರ್ ಬ್ಲಾಸ್ಟ್ ಆಯ್ತಂತೆ, ಇಲ್ಲಿ ಚಾರ್ಜರ್ ಬ್ಲಾಸ್ಟ್ ಆಯ್ತಂತೆ ಅಂತ ಬಹಳ ನೆಗೆಟಿವ್ ಪಾಯಿಂಟ್ಸ್. ಅಂದ್ರೆ ದಟ್ ಹ್ಯಾಸ್ ಹ್ಯಾಪನ್ಡ್, ಬಟ್ ಬಿಕಾಸ್ ಆಫ್ the batteries are the initial stage of evolution. So now the evolution of batteries are increased to the higher standards. Now we cannot we are less used to prefer reason somewhere battery EV vehicle going to blasted, those things. So finally, safety consideration is very important in the electric vehicle. Those are with respect to the electrical safety, battery safety and mechanical safety. With respect to the electrical safety, it should protect the user from giving the electrical shocks, short circuits, high voltage leakage and arc flash. Prediction methods that are taken to avoid these type of electrical failures: high voltage installation, isolation monitoring, fuses, contactors and emergency disconnects. Battery safety, over charging avoid ಮಾಡಬೇಕು, over discharging ಇರಬಾರದು. ಅಂದ್ರೆ ಓವರ್ ಚಾರ್ಜಿಂಗ್ ಇಂದನೂ ಬ್ಯಾಟರಿ ಜಾಸ್ತಿ ಚಾರ್ಜ್ ಮಾಡಿದ್ರು ಇಟ್ ಮೇ ಲೀಡ್ಸ್ ಟು ದ ಬ್ಲಾಸ್ಟ್. ಸೊ ದಟ್ ಇಸ್ ಒನ್ ಆಫ್ ದ ಕನ್ಸರ್ನ್. ಓವರ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್ ಆಲ್ಸೋ, ಇಂಟರ್ನಲ್ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಆಲ್ಸೋ, ಥರ್ಮಲ್ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆಗಬಹುದು, ಸೆಲ್ ಬ್ಯಾಲೆನ್ಸ್. Mechanical safety protects battery pack during crash, vibration, impact, and water ingress. So this completes your first concept related to the sixth module, that is history and evolution of electric vehicle, EV powertrain architecture and energy flow, battery types, performance characteristics, and safety consideration. One activity we will have now, that is with respect to see. ನೋಡಿದ್ದೆ in the beginning, there are two different EVs are there, EVA and EVB. EV is the battery capacity 40 kilowatt hour, EVB is the battery capacity 60 kilowatt hour. EV is the motor power 90 kilowatt, EVB is the motor power 150 kilowatt, and the ranges of A is 300 and it is 450. Top speed is 140 kilometer per hour, top speed is 180 kilometer per hour. It reaches from 0 to 100 km per hour reach ಆಗಲಿಕ್ಕೆ 9.5 seconds ಆಗುತ್ತೆ, ಇದು 6.2 seconds ಆಗುತ್ತೆ. Torque of AV is 200 Newton, 200 Newton. Torque of EVB is 350 Newton. So my question, I will ask one question, one by one to you. Which electric vehicle has better acceleration?
EVB, sir.
Which electrical vehicle has better acceleration?
EVB.
How?
ಸೊ ಪ್ರಿವಿಯಸ್ ಅವಾಗಲೇ ಹೇಳಿದ್ವಲ್ಲ ಸರ್, ನಾವು ಇದು ಕಿಲೋಮೀಟರ್ ಪರ್ ಅವರ್ ಅಲ್ಲಿ ರೀಚಸ್ ಆಗುತ್ತೆ. ಇದು 0 to 100 ಕಿಲೋಮೀಟರ್ ಅವರ್ ಅಲ್ಲಿ 6.2 seconds ತಗೊಳುತ್ತೆ. ಬಟ್ ಇದು ಕಂಪೇರ್ ಟು EVA ಅದು 9.5 seconds.
Where EVA takes 9.5 seconds. Very good.
Yes.
Second question. Which electric vehicle is better for city driving? Which electric vehicle is better for city driving? A or B? Which electric vehicle is better for city driving?
EV.
ಯಾವುದು A ನ B ನ?
B, sir.
B. Why?
ಕೆಪಾಸಿಟಿ ಕಂಪೇರ್ಟಿವ್ಲಿ ಜಾಸ್ತಿ ಇದೆ ಸರ್. ಮೋಟಾರ್ ಪವರ್ ಜಾಸ್ತಿ ಇದ್ದಂಗೆ ಸ್ಟೋರೇಜ್ ಕೆಪಾಸಿಟಿ ಚೆನ್ನಾಗಿರುತ್ತೆ ಪವರ್ ಕನ್ಸಂಪ್ಷನ್.
ಬಟ್ ಕಂಡೀಷನ್ ನೋಡಿ, ನಾನು ಏನು ಕಂಡೀಷನ್ ಕೇಳ್ತಿದ್ದೀನಿ?
ಸಿಟಿಯಲ್ಲಿ ಸರ್ ಎ ಆಗುತ್ತೆ ಸರ್.
ಸಿಟಿಯಲ್ಲಿ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ, ಟಾಪ್ ಸ್ಪೀಡ್ ಯಾವ್ದು ಇದೆ? ಬಿ ಇದು 180 ಇದೆ, ಎ ಇದು 140 ಇದೆ. ಸಿಟಿಯಲ್ಲಿ 180 ರೀಚ್ ಆಗಕ್ಕಾಗುತ್ತಾ?
ಆಗಲ್ಲ ಸರ್. 140
ರೀಚ್ ಆಗಲ್ಲ. ಬಟ್ ಟಾಪ್ ಸ್ಪೀಡ್ ಬಂದ್ಬಿಟ್ಟು ಯಾವ್ದು ಕಡಿಮೆ ಇರುತ್ತೆ ಅದು ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಎಷ್ಟಿದೆ? 140.
ಎ.
ಮತ್ತೆ ಇನ್ನೊಂದು ಕಂಡೀಷನ್ ತಗೋಬಹುದು. ನಾವು ಸಿಟಿಯಲ್ಲಿ ರೇಂಜ್ ಎಷ್ಟು ಇರುತ್ತೆ? ಮ್ಯಾಕ್ಸಿಮಮ್ ನೀವು ಎಷ್ಟು ಕಿಲೋಮೀಟರ್ ಬರ್ಬೋದು? ವಿಚ್ ಇಸ್ ಮೋರ್ 300 ಇದೆ, ಇನ್ನೊಂದು 450 ಇದೆ. ಸಿಟಿಯಲ್ಲಿ ನಾವು 450 ರೀಚ್ ಮಾಡ್ಲಿಕ್ಕಾಗುತ್ತಾ? ಕಿಲೋಮೀಟರ್ ರೀಚ್ ಮಾಡ್ಲಿಕ್ಕಾಗುತ್ತಾ? ಇಲ್ಲ. ನಾವು ಹೋದ್ರೆ ಒಂದು 50-60 ಕಿಲೋಮೀಟರ್ ಬಂದ್ಬಿಡ್ತೀವಿ ವಾಪಸ್. ಸೊ ಯಾವ್ದು ಪ್ರಿಫರ್ ಮಾಡಬಹುದು? ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಎ ಇಸ್ ಪ್ರಿಫರ್ ಫಾರ್ ದ ರೂರಲ್ ಕಂಡೀಷನ್, ಸಾರಿ ಅರ್ಬನ್ ಕಂಡೀಷನ್ or city condition. Then which electric vehicle is better for highway driving? highway ದಲ್ಲಿ NH4 ಅಲ್ಲಿಂದ ಬೆಂಗಳೂರಿಗೆ ಹೋಗ್ತೀವಿ ಅಂದ್ರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಎ ಪ್ರಿಫರ್ ಮಾಡ್ತೀರಾ, ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಬಿ ಪ್ರಿಫರ್ ಮಾಡ್ತೀರಾ?
ಬಿ ಸರ್.
Obviously it is B. ಯಾಕೆಂದ್ರೆ ಸ್ಪೀಡ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಸ್ಪೀಡ್. ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ನಾವು NH4 ಅಲ್ಲಿ ಸ್ಲೋ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಹೊಡೆಯಲ್ಲ, ಹೈ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಹೊಡಿತೀವಿ. ಇಟ್ ಹ್ಯಾಸ್ ಎ ಟಾಪ್ ಸ್ಪೀಡ್. ಮತ್ತೆ ಇಲ್ಲಿಂದ ಬೆಂಗಳೂರಿಗೆ ಆಲ್ಮೋಸ್ಟ್ 250 to 300 ಕಿಲೋಮೀಟರ್ಸ್ ಆಗುತ್ತೆ. ಮನೆ ರೀಚ್ ಆಗಲು 300 ಕಿಲೋಮೀಟರ್ ಜಾಸ್ತಿ ಆಗಬಹುದು. ಸೊ ಒಂದ್ಸಲಿ ಫುಲ್ ಚಾರ್ಜ್ ಆದ್ಮೇಲೆ ಇದು 300 ಕಿಲೋಮೀಟರ್ ವರೆಗೂ ಹೋಗುತ್ತೆ, ಇದು 450 ಕಿಲೋಮೀಟರ್ ವರೆಗೂ ಹೋಗುತ್ತೆ. ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ನಮಗೆ ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆದಂಗೆ ವಿ ನೀಡ್ ಟು ಗಿವ್ ದ ಜಾಸ್ತಿ ರೇಂಜ್ ಅಲ್ಲಿ. ಸೊ EVB electric vehicle B prefers for highway conditions. Which electric vehicle would you prefer perform better on hilly roads? ಬೆಟ್ಟದ ರೋಡ್ ಅಲ್ಲಿ ಗ್ರೇಡಿಯಂಟ್ ಜಾಸ್ತಿ ಇದ್ದ ಕಡೆ ಯಾವ ಎಲೆಕ್ಟ್ರಿಕ್ ವೆಹಿಕಲ್ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಚೆನ್ನಾಗಿರುತ್ತೆ?
ಸೇಮ್ ಸರ್, EVB ಸರ್.
ಇನ್ನು ಯಾವ್ದಾರ ಆನ್ಸರ್?
ಐ ಟಾರ್ಕ್ ಬೇಕಾಗುತ್ತೆ ಸರ್. ಅವಾಗ್ಲೇ ಹೇಳಿದ್ವಲ್ಲ ಸರ್, ಈಗ ಸ್ಟಾರ್ಟಿಂಗ್ ಐ ದಿಬ್ಬ ಹತ್ಬೇಕಾದ್ರೆ ಟಾರ್ಕ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ ಸರ್, ಹಂಗಾಗಿ
EVB ಜಾಸ್ತಿ. EVB 350 ಇದೆ, EVA 200 ನ್ಯೂಟನ್ ಮೀಟರ್ ಇದೆ. ಸೊ ಆಬ್ವಿಯಸ್ಲಿ ಫಾರ್ hilly condition and highway we will prefer the electric vehicle B. For the city limits we will prefer the electric vehicle A. Very good.
ಸ್ಪೀಡ್ ಕಡಿಮೆ ಇರುತ್ತೆ ಮತ್ತೆ ಟಾರ್ಕ್ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ ಸರ್. ಹಾಂ ಸರ್.
Answer these questions. Over.
ಹಾಂ ಸರ್. ಸರ್ ಹಂಗೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬಿಡ್ತೀವಿ ಸರ್, ಇಲ್ಲ ಅಂದ್ರೆ ಮತ್ತೆ ಗೂಗಲ್ ಸರ್ಚ್ಗೆ ಹೋಗ್ಬಿಡ್ತೀವಿ ಸರ್. ಅದಕ್ಕೆ ಹಂಗೆ ಹೇಳ್ಕೊಂತ ಹೋಗ್ತೀವಿ, ಹಂಗೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಬಿಡ್ತೀವಿ ಸರ್. ಹಂಗೆ
ಅಲ್ಲ, ನೀವು ಕೌಂಟ್ ಬರ್ಕೊಳ್ರಿ. ಕೌಂಟ್ ಗೊತ್ತಾಗಲ್ಲ ಯಾರು ಕರೆಕ್ಟ್ ಇದೆ, ಅಷ್ಟು ಕರೆಕ್ಟ್ ಇದೆ. ಈಗ ನೀವು ಹೇಳಿದ್ರೆ ಇನ್ನೊಬ್ಬ ಕರೆಕ್ಟ್ ಇರ್ಬೋದು, ತಪ್ಪು ಇರ್ಬೋದು.
ಓಕೆ ಓಕೆ.
ಮಾಡಿರ್ಬೇಕು ಕರೆಕ್ಟಾಗಿ ಯಾವ್ಯಾವ ಕ್ವಿಝಲ್ಲಿ ಯಾರು ಎಷ್ಟು ತೆಗೀರಿ ಅಂತಂದು ಸುಳ್ಳು ಮಾಡ್ಕೋಬೇಡ್ರಿ.
Yes, sir.
Mamta?
Yes, sir, completed.
So answer. First one. First question. Answer is answer. First question.
Option B, sir.
Okay. Second question. Mamta.
Battery, sir.
Okay. Third question. C. Nekan tokni rather right akatodi. 3C, 4B, 5B, 6B, 7B, 8A, 9C, 10B, 11B, 12A, 13C, 14B, 15B, 16A, 17B, 18B, 19C, 20B, 21B, 22A, 23B, 24C, 25B. ಎಷ್ಟು ಕರೆಕ್ಟ್ ಆಯಿತು? ಹೇಳ್ಕಂತ ಹೋಗ್ರಿ ಒಬ್ಬೊಬ್ರು.
Sir, 22, sir.
22. ಸ್ನೇಹ?
22, sir.
ಮಮತಾ?
20, sir.
20?
20, sir.
20. ಓಕೆ, ನೋಟ್ ಮಾಡ್ಕೊತ ಇರ್ರಿ. ಅಸೈನ್ಮೆಂಟ್ ಪ್ರೆಸೆಂಟೇಷನ್ ಬರ್ತಿರಲ್ಲ ಅವಾಗ ಎಷ್ಟು ಯಾರು ಜಾಸ್ತಿ ಬರುತ್ತೋ ಚೆಕ್ ಮಾಡೋಣ. ಓಕೆ, ನಾಳೆ ಎಷ್ಟು ಗಂಟೆ ಕ್ಲಾಸ್ ತಗೊಳ್ಬೋದು?